All right, let's chill. What do you
brother.
guys think about how we have 60 nautical miles per degree, and that works perfectly on a flat Earth with a curved visual space, and that means we can explain all celestial navigation and all positions of the sun, moon, and the stars perfectly on a flat Earth with all the math to back it up, and you got predictive capability at any location.
Would that be
We're talking
perspective?
about Steam. Shut up.
Would that be perspective?
Yes, that's
Then
exactly
I
what it
agree
is.
with it. Then
Yeah.
I'm
Perspective
fully on board with it.
perspective is just an art drawing tool. That's all it is.
Hey, I got a question. Hey, if visual space in perspective, if perspective is Euclidean, then why do railroad tracks appear to converge?
Reasons.
Reasons. Hey,
Trigonometry.
hey,
Simple
do we agree that?
trigonometry. I understand if you don't get it. I mean, it's just simple trigonometry.
Yeah, like, is it one of the main postulates of Euclidean geometry that parallel lines do not intersect?
Right.
They
Oh,
just
so
appear to
Yeah, they're
they just appear to do so
appearing
because of an art technique.
wait.
That's
So if they appear to do
perspective.
so, yeah, then perspective can't be Euclidean, then, right?
Right, and they're also
Railroad
supposed to
tracks.
be the opposite of that too. They're supposed to go in and come back out if it was a ball's perspective.
What? No,
And it
railroad
doesn't
tracks.
matter. You can put 100. I'm going, Jeremy. I always let you go. I'm going this time. If you put 100 railroad tracks next to each other and then on top of each other, like the same distance apart, they're going to all appear to go to the same point due to your perspective.
Exactly. They'll go to a focal point, then they'll widen back away. Yep, 100%.
Only
You
in
guys
an
get
art
the
room.
you guys get the argument, though?
Yeah,
Can
but
any-
doesn't
any
this
fighter still
implicate
win?
the sun? The sun has parallel light rays then because of corpuscular and anti-corpuscular rays. Then wouldn't that be
No.
their argument?
Wait,
Which
No.
the argument is.
No.
Which the argument is we're not seeing in Euclidean geometry. Is that what you're saying?
And what's the what's the argument that refutes the claim that we do see in Euclidean geometry?
well, are you saying that we each individually have our own perspective, and if we have multiple viewers viewing the same thing, you can't just put that all as one perspective, meaning you can't just, draw that down to this one central location and give it a singular curvature?
No,
It's
this
worse
is
than
just a
that.
red
If
herring
you're
fallacy.
moving. Yeah. And if you're moving, the perspective to that point changes. That point changes.
Can anyone still man the argument that refutes the claim that perspective is Euclidean? Because just let me lay this out. I mean, the globe requires the claim that perspective is Euclidean.
Eric, come here.
The entire globe model requires the claim that we see in straight lines and perspective is Euclidean. If it's not, the entire globe model is immediately falsified. Immediately. And the flat Earth model becomes 1,000 times more viable. And actually, you can't have 1,000 times more viable than nothing anyway, because that would still be nothing. So anyway,
But railroad tracks are still straight.
Can I say something?
no, that's the point. This is how you do it before Jesse jumps in and just mind rapes us. Just so I want the flat earthers to make sure they understand. Okay, what is in Euclidean geometry? One of the primary postulates is that parallel lines do not intersect. So that means, of course, if you have two straight lines parallel to each other, no matter if they went infinitely, they're never going to intersect. That is literally a postulate of Euclidean geometry. Okay, and it's just common sense. So in physical reality, two parallel lines never intersect. In Euclidean geometry, two parallel lines never intersect. They never appear to intersect because it just describes physical reality. So if we now say Euclidean or perspective is Euclidean geometry, then we have a problem because we see two parallel lines in physical reality, like railroad tracks, appear to converge and intersect. This proves that perspective is non-Euclidean, because if perspective was Euclidean, then they would not converge.
You can still draw them in straight lines, though.
What kind of response is that?
Wait.
I don't see how it's non-Euclidean. I don't understand that statement.
I know that's why.
Because in Euclidean geometry, parallel lines do not converge, right? But we're seeing them converge because the railroad tracks are parallel, but we're seeing them converge. But in Euclidean geometry, they don't converge. So we can't be seeing in Euclidean geometry. Otherwise, we wouldn't see them converging.
So we see
Yeah,
a
let me ask you this.
non-Euclidean visual space.
Objectively, yeah. If we have a railroad track, right? And so there's two lines that are parallel in physical reality. They're in physical reality. So we know that these lines on the railroad track are in physical reality and they're parallel. So could we describe those with Euclidean geometry in
Yes.
physical reality?
Yes.
Correct. Okay. So then if we describe them in physical reality, what we'll do is we'll have two lines that are just going straight to parallel to each other infinitely, however long the railroad track is. Okay, now when we look at the railroad tracks in the distance, right, we see that they appear to converge. That's distinctly different than how we would be describing the railroad tracks in physical reality with Euclidean geometry, right?
No.
No, he said no. Okay, when we describe the railroad tracks in physical reality with Euclidean geometry, do you agree that it would be two lines that are parallel to each other and that they would remain parallel to each other until the end of the railroad track?
They remain parallel, but if you were to actually calculate what the angular distance between, say, two tracks 3 feet apart at 100 miles would be, it would only be 0.0003 degrees of separation, which without magnification would appear to be converging, even in Euclidean geometry. And we can calculate this, right?
So they
You,
appear to merge, so they merge, right? So they
yeah,
no longer become parallel.
I don't get it.
That's why there's something
I,
called perspective geometry.
Yeah, this is what I was trying to. He just invoked perspective geometry, but specifically like angular size, and then conflated the two, and then acted like it was Euclidean. This is what I'm trying to say, bro. Like, I want to make sure flat earthers understand it because I don't dispute the Glovers won't, because they have to have Euclidean geometry. And I let the cat out of the bag that if it's not true, the whole globe's wrong. But I just want to make sure the flat earthers get it. If perspective is Euclidean, that means parallel lines do not converge or intersect. So that means that there is objectively a distinction between how we see and how we describe physical reality with Euclidean geometry. How we see is different than physical reality. So if there's something that we can describe accurately with Euclidean geometry in physical reality, but then the actual like appearance of those objects are different within perspective, that means it cannot be described with the same thing.
Correct. So let me ask Jesse a question. Jesse, is there such a thing as parallel lines in perspective geometry?
What do you mean by parallel? As in appearing to be parallel?
Holy
Or
shit, no. Are
so
there such things as parallel lines in perspective geometry? Googling intensifies.
Yeah, and then he just doesn't respond like when it's a tough question. Just disengage, because like he does this on purpose.
Yeah, I thought maybe you were going to come in and tell DMOC that he was wrong about, breathing in electricity or something.
I would say that
chill,
you
chill,
could
chill.
have if you did it in orthographic view and then you draw the angle of view from the eye to the object with increasing with the angle to that object decreasing with distance. I don't see why you couldn't do it in Euclidean.
Okay, Napalm, you want to repeat your question, I guess? Oh my god.
So-
This is frustrating for me because it's like you guys aren't stupid. You know exactly what's being said. You've internalized the belief that perspective is Euclidean, and so you're just not actually addressing what's being said with specificity. I mean, I can give you a university paper saying the same thing. You'll say that they're quacks. It's like, no, the easiest and most direct refutation of the claim that perspective is Euclidean is that, for example, we see that due to perspective, parallel lines appear to converge.
linear perspective?
We're not there yet. We're not there yet. When we look out in reality, parallel lines appear to converge. Euclidean geometry specifically states that parallel lines will never converge.
But does it state that they will never appear to converge, or is it possible for two parallel lines to appear to converge in Euclidean geometry, even though they don't actually converge, right?
We know that the parallel lines can appear to converge, even though in physical reality it can be described by Euclidean geometry. That's the whole point. That proves that perspective is different than physical reality that can be described with Euclidean geometry, Jesse. You just made my point.
Yeah, Euclidean geometry does not go and start telling you like, well, you know, how you should look at things from the side, etc. It just gives you a proof with an angle, degrees, and formulation of triangles, etc.
So
It's
what?
just a fact. It's just a fact that perspective is non-Euclidean because perspective specifically does something that Euclidean geometry says is not possible. And if you say, oh, does it say appear? You're the one claiming that perspective is accurately described by Euclidean geometry, which has specific postulates. There isn't a different version of it. It's just Euclidean geometry, which means if we're going to describe what we see accurately, then we're going to have to invoke something other than a geometry that claims parallel lines never converge, because we see parallel lines converge due to perspective. That proves that perspective is non-Euclidean.
They appear to converge. They don't actually converge.
That's what perspective means. Oh
Yeah,
my
They
God.
appear
that's
to,
what-
yes.
When you say appear, where you're saying how we see it, appearance, how we see it.
Yeah.
We don't.
Yeah, they look
we
like
don't
they
see-
converge. They don't actually.
That's
Yeah,
my
so
point.
we're not. Yeah.
We see them converging, though.
That's literally my point, bro. Both of you guys are responding by repeating my point as if it's a rebuttal. My point is that in physical reality, they don't converge. They're just railroad tracks. They're parallel to each other. They're a certain distance away from each other, and they are going to remain parallel the whole length of the railroad track. They never converge.
Yeah, let me read this from Wikipedia for perspective geometry in the section called Axioms of Perspective Geometry. Any given geometry may be deduced from an appropriate set of axioms. Perspective geometries are characterized by the elliptic parallel axiom that any two planes always meet in just one line, or in the plane any two lines always meet at just one point. In other words, there is no such thing as parallel lines or planes in perspective geometry. So there's no such thing as parallel lines or parallel planes in perspective geometry.
There
How
you go.
doing?
Which means it can't be Euclidean, because specifically a primary postulate of Euclidean geometry states parallel lines never converge or intersect.
So they have two fundamentally different axioms, thus cannot be applied equally.
So what would, in Euclidean geometry, what would be the angular size of something that was 3 feet across and 100 miles away? Would it be different than what we see?
Stop diverting to angular size.
Well, angular size is important because that's what causes the train tracks to appear to
Perspective.
converge.
That's not what we're talking about. No, it's not what we're talking about.
Well, why then does this curved visual space affect only things in the vertical axis and not right to left? When something moves away from us in a straight line, in reality, if Earth is flat, it appears to drop down faster than perspective.
Stop
math
changing the
says.
subject.
But if
Stop changing the
it doesn't,
subject.
it doesn't change right to left faster than perspective math says. What's with the downward bias in perspective?
So we're supposed to just allow Jesse to come in, intentionally avoid the actual point, and then completely bastardize it by changing it to two different points. No, I think we're not going to do that, actually. I'm going to make an executive decision and say, no, we're actually not going to do that.
So
Here,
in
here.
perspective
Well,
geometry, are there any parallel lines, Jesse?
well, the thing is, in perspective geometry, things decrease in size with distance uniformly, top, down, left, right, diagonal, whatever.
Can you
It
cite that?
doesn't favor one axis. That's easy. Listen, demonstrate.
Is he roboting for everybody else?
Yeah, he's roboting, but all they can do is change the subject. So the Globers sit out. Just sit out of the conversation. This is for flat earthers anyway. You guys can only change the subject. We get it. You can't comprehend the simplicity of the argument. We get it. Whatever. Fine. Sit it out. Don't come in and just start raping us with red herring fallacies.
Yeah, I
So,
thought they were being deceptive at
indoctrination
first, but it seems
session
like
then.
They really don't understand the point.
You're just diverting away from the point. You guys can't ever just be straightforward and honest about a point. You always have to use tactics and be squirmy, and it's just a waste of time.
Yeah, you're
Yeah, but
affirming
they-
the consequence of the conversation. Before we can really get into the conversation, that's not enjoyable.
Well, they literally
Yeah, like-
said they appear to converge but don't actually, and that's the entire point. So at first I
know.
thought they were just being disingenuous, but now I'm thinking maybe they really truly don't understand.
No, they don't. But the point is that they were asserting my point to me, which means that they conceded. So we don't really need any further input, whether they get it or not.
That's true.
Yeah. So just for the flat earthers, that's the point. Is it shows that perspective is distinctly different than Euclidean physical reality. Perspective is non-Euclidean.
So with it, would you say that if you're taking a measurement to a perspective effect, you should not apply Euclidean geometry to it?
Just a sec, bro. I'm ordering food. Can you repeat what you said?
Yeah, I was saying, would you say that if you're taking a measurement to a perspective effect, you should not apply Euclidean geometry to that measurement?
Sorry, just a second, bro.
I would say that like a chessboard is drawn in Euclidean geometry. I think we can all agree to that, right angles and such. But if you're going to draw that chessboard viewing it from an angle, you would have to draw it in Euclidean geometry or in perspective geometry to make it look like it does when you're looking at it, right?
So again, you can see. Okay.
So I don't see how it debunks
Yeah.
Euclidean geometry.
You just said it. We
Yeah,
would
you
have to
said
draw it. We would have to draw it different than Euclidean geometry because if we drew it like we saw it, we would have to draw it to where the parallel lines were converging.
Converge. Da da da.
It doesn't debunk Euclidean geometry.
Yeah, that was a weird way of saying it. Yeah,
It
does
Yeah.
debunks
not.
Euclidean perspective.
Yeah,
It's just
exactly.
it's
We don't
just a
see in that. Yeah,
specific type of geometry. It's just you're misapplying a specific type of geometry.
yeah.
The man-made inferences, ideas, comprehended laws or structures most of the time can't be actually put 1,000,000% to reality anyway. There's always a exception to most of the rules.
But if we have, say, 3 parallel sets of train tracks, we're standing on the middle train track and looking straight ahead, and the train tracks are perfectly straight. And there's a train on the left and on the right tracks to us going away from us. Those trains will appear to get closer and closer and closer to the middle track, but they will never appear to cross over. And
Yeah, but
that's
go ahead, Jesse.
that's what I'm not understanding. That in the right to left axis, it matches. We can take the spacing of the sets of tracks, the distance of the train, and calculate the exact angle that we will see. So it acts Euclidean in the right to left axis, but for some reason, and this is the elephant in the room that no one's looking at here, in the vertical axis, it's different. It doesn't follow the same math. It's a similar math, but it has an 8 inches per mile squared drop to it.
So just the
No,
same thing.
if
Like
you
avoid
do
the
it-
actual point and change the subject again, and that's all you ever do, Jesse. You're clearly using tactics to avoid the actual point.
It's an honest.
Objectively.
Yeah, you said it yourself, Jesse. If we have the train tracks, the trains on the left and the right will appear to get closer together. In Euclidean geometry, they don't get closer together. So we're seeing something different than Euclidean, right?
Address that part first. Stop responding with their different point that you want to force in the conversation. Because no one's scared of your point. We're not just going to play the game where we don't make a conclusion because you want to avoid it and that you just get to dictate that we're going to talk about what you want to talk about to get away from it. It's just bad faith, bro.
We've got angles in Euclidean geometry, angles and distance, right?
What kind of response, bro?
Address the point that was made to you, Jesse. This is not difficult.
Well, the point is that Euclidean geometry, angles and distances, hold up as far as the right to left axis.
Oh my God.
For
Maybe
some
just sit this one out. Maybe just sit it out, right? Because we don't have to do this. You know that, right, Justin? We don't have to talk to you for an hour where you intentionally avoid the point we make. You know we don't have to do that, right? You're not like our boss. You're not our principal. You're not our daddy. Like, we don't have to sit here and be like, okay, we have to listen to Jesse, avoid what we're talking about, and control it, what we talk about to a different point, and then play games for an hour. We don't have to do that. You realize that, right?
I'm just trying to understand how to apply what you're saying to the real world, to the things we observe in reality that look like the Earth is a globe.
No, actually, you're avoiding what's being stated by trying to skip over it and force another point to try to talk about how you believe the Earth's a globe. That's what you're actually doing. You've been called out for it 4 times now, and you're going to do it again. For guaranteed, you're going to do it again. So just sit out. Just sit this one out. If you're just going to use bad faith tactics, just sit it out. Can any other glober respond with like good faith? We can move on to the consequences or conclusions after we actually address the first point, right?
And that's fair. That's more than fair, by the way.
Yeah. Okay.
Yeah,
so
that's how discussions work. Yeah.
Yeah. Perspective cannot be Euclidean, bro. Okay. Now this is a big deal. Whether or not a glober like shorts out and they're like, but why do things look like they drop in the distance though? Anything that they can come up with to avoid it doesn't change anything. It's just a fact that perspective is non-Euclidean because Euclidean geometry says parallel lines will never converge and never intersect. Okay, now when we see things that we know to be parallel in physical reality, and we look in the distance, they literally appear to converge. That proves that the way we are seeing the physical parallel objects is different than it is in reality. There's a distinction between physical reality and how we see physical reality. One of them is, in this scenario, Euclidean, and one of them is non-Euclidean because the parallel lines are appearing to converge. So perspective is non-Euclidean. Now, this has major implications, though, because the entire globe model was engineered assuming Euclidean geometry for perspective, drawing infinitely long straight lines as to how we see, and then creating a globe model when we see things curve and claiming it's because the Earth is curving. That is clearly what happened. They can't even explain railroad tracks. So their side is dismissed. It is not viable on its face.
But shouldn't this curved visual space make a set of straight tracks appear curved left to right as well?
What? No, they appear to converge. They appear to converge.
At a central point, yeah.
So why would that not be possible in a Euclidean coordinate system?
We just explained why it's not possible. Hey, Jesse, either sit out of the conversation or address what. Can you still man the argument?
I'm trying to understand the argument.
Can you still man the argument?
I think you're saying that because parallel lines don't converge, that therefore it's not possible for them to converge, to appear to converge.
Well, let me just read this.
No,
In
he can't still man
it. He's just going to continue to dish
Of
gallop
course.
and divert. So in mathematics, perspective geometry is the study of geometric properties that are invariant with respect to projective transformations. This means that compared to elementary Euclidean geometry, perspective geometry has a different setting perspective space and a selective set of basic geometric concepts. The basic intuitions are that projective space has more points than Euclidean space for a given dimension, and that geometric transformations are permitted to transform the extra points called points at infinity to Euclidean points and vice versa. So it's a transformation. You have to transform it. 8 inches per
Yep.
mile squared, maybe.
Yeah. So this is interesting, right? Because we see in non-Euclidean geometry, well, everything changes. And then now we can actually start to map out our visual space because we can make measurements of stuff in the sky. You know, the very thing that the Globers claim. Let me just jump to the home run here. The flat Earth position is that everything appears to converge into the horizon because of perspective, such as planes going over your head, such as railroad tracks, hallways, clouds going down in the distance. Everything converges. Things above you come down and compress and converge. Things from the bottom come up and converge. Everything does this due to perspective. And that also happens with the stars. So it happens with everything. Perspective happens with everything. The globe position is, yes, it happens with everything except for the stars. That is a stillman. That is objectively the situation. Wait, who's more logical here?
It seems to me that logic would say that perspective would have an application to the celestial objects as well.
Right. Like because perspectives apply to everything that we see, right? So if we're looking at the sky, then why would perspective not be a variable? So that the globe position is, everything compresses to the horizon due to perspective. In reality, everything does that. But that the stars are different. They're the exception. Stars don't compress and come down to the horizon because of perspective. Flat Earth says, yes, they do. So we actually have the superior position. They're making it's called special pleading. They're just making a special pleading argument.
Yeah, this is why I say they always just take the planar aspect of our reality and give that to the stars, and then take the spherical aspect of our perspective and put that below our feet. Because when you have multiple people in different positions viewing something, you have multiple perspectives that each person is viewing from. So there's going to be perspective at each individual observer's observation point. But what they do within celestial navigation is they say, actually, all the light from the stars is coming in parallel. So there's only one perspective that everybody is using. So ultimately, they draw every single observer to the center of what they claim is a sphere, right? To the center of the earth, and give the stars a parallel Euclidean perspective, which just doesn't match reality. So ultimately, you draw each observer to a central location and a central point of perspective, thus giving you the celestial sphere, which they claim is the curvature of the Earth. But we know it's just a conglomeration or a transformation of perspective.
Perfect. But also, dude, like the best thing about this part is if the globe is also using this logarithmic expression and then limiting you to, like, say, celestially navigate to only the linear portion, they will be saying to, like, hey, like, that's not really correct. And if you used it linearly all the way through, it would break down. It would break down, lower than 15 degrees and above 70 degrees, precisely where they limit you to navigate with that perspective only, right? So the big trick to get them to think, or for them to get you to think that linear perspective scales infinitely, because they need you to believe in light speed and all that shit later with no light attenuation plus the inverse square law, right? So the whole thing is built and predicated upon this lie, but actually the math, if you let it actually go out to each side, perfectly explains what you see, but they only limit you to the linear portion of that. So that's kind of the big trick.
Yeah, just make sure everyone knows what he's saying. So, like, when they do this celestial navigation or whatever, 16 nautical miles per degree, they tell you that you can only reliably take these measurements between 15 and 70 degrees. And if you fall below 15 degrees or go above 7 degrees, that they can't be reliably used. It's unreliable. So they isolated the portion of the measurements that would work. And he's explaining like, oh no, we see in curved visual space, and they're just like isolating the linear portion of it, the portion that can be treated as linear with accuracy, and then claiming that it's all linear, but you just can't use it in reality. It's such a trick. It's not that flat Earth can't explain what we see in the sky. It's that we explain it significantly better.
Yeah, and their claim for the reason of that difference, right, as you get closer to the horizon, is what they say is refraction, right?
Well, why does it change above 70 degrees then?
That's a good question.
There's no way out of this. Yeah, I mean, me and Shane talked about it last night. So shout out to Shane for doing all the math in it. It's like it's just game, set, match, bro. Like I mean, I want to hear a Glober articulate what's wrong with the math and some type of rebuttal because they haven't been able to do so yet.
Or at least someone asked me how we did it. I mean,
and they don't want to know. They don't want to know the truth. They don't want to know the truth.
Well, why do things change size and distance from left to right then? Sorry, I'm just joking.
They have to avoid the truth. Like they get like a normal person that was just I'm interested in what's going on in reality. What's the truth? They'd be like, wait, what are you talking about? How does that work? They don't even want to know. They don't want to hear it.
Yeah, I have a lot of questions for Shane just in general to fucking wrap my head around it myself. It's just like that's the honest approach. It's pretty interesting.
Well, maybe he should start off with how he did it.
Shane.
There you go.
All right, Shane, keep in mind that these people are not familiar with what you're about to tell them. Okay?
Right. Right. Yeah. Well, first off,
Shane does what I used to do in mine. Like he talks quickly with complex issues. Just
you got it.
Break it down, man. They've never heard of it.
All right.
Screen share, please.
We can try. Screen share. Maybe. But like, so first of all, dude, like the celestial navigation thing, Napalm, exactly what you said. I took that from Ruhif, where he was like perfectly describing how it's, exclusive to him. It can never work for us. And I was like, so that thing that you're on top of, that you pretend to be on top of, where you take an angle to the center of, like if say I was in a celestial sphere of that same size that had moved with me across the flat point, and I was already at that center, I could just use that angle, couldn't I? Yeah, exactly that. So that's how you fix celestial navigation. You're at the center of the thing that they pretend to be on top of. Super easy. Not even hard.
Pause. You got to explain it, right? So, do you guys know how you see, like, imagine just linear trigonometry, right? And then you have, like, the radial trigonometry where they pretend to get the center of the earth, right? Like, where they show you, like, oh, well, we'll use the center of the earth, and then along with where you are on the earth. So, basically, he's saying you don't have to be on top of a celestial sphere anymore. Like that's where the observer is in Ruhif's picture. If you look right there, where the observer is on this imagined sphere. So, anyway, continue.
Yeah, you guys get what Shane said, right? It's pretty simple.
Right, because I've always argued that like you had this sphere around you, the limit of your vision, azimuthal grid of vision, or whatever we want to call it, personal dome, right? It's always been the same thing. It's always described an optical, like visual limit of your space. And now with like the celestial navigation, you can math it out. And we did it with like simple trig, and we used a unit circle, which is just like a unit of scale. When you're doing trig, you can use that. Usually it's a radius of 1. It makes the other sine and cosine angles easy to compute, easy to work with, easy to scale. Except I set that instead of 1 to 3959, which would be not only the radius of your optical like spherical dome that you bring with you, but backwards compatible, derived from the angular resolution limit and our favorite Rayleigh criterion.
Yeah, bro, what a coincidence, huh?
So there's some wonderful math for that, and that's why it's the basis of our, optical limit. And then what we do with the unit circle, once we have that radius set, is we use some basic trig, sine and cosine, to approximate length and height, which would be ground position and height, right? So we do that at each latitude all the way through, keeping that visible dome around us as the radius that you could see. And then when you get all the way to the end, you get to figure out what Gleam figured out on his linear track, right? is that when you do 69 statute miles per degree times 90 degrees of latitude between the North Pole and the equator, you get linearly, if you were to do linearly distance, that would be 6210 miles, 6,210 miles, which would be the linear distance of the extended geodesic arc of the radius of the sphere of the Earth. Right?
I'm done.
Is it,
Let's just pause. Let's make sure everyone gets it.
Yep.
So if you start at the top of a ball, right, the North Pole, top of the ball, and then you come down to the equator on a sphere, right? That's going to be 6,210 miles in their model. If you start at the top of a ball at the North Pole and you go straight down to the middle, that's going to be 3,959 miles. Okay, so it's like obviously you have the arc, it's curving, so it's longer to get to the middle. So if you straightened out that curved line on the surface, it's going to be longer than the center one. So that's the way they interpret that relationship. Is that the statute miles is based on you curving on a surface in an arc. Everyone gets that?
Right, so we have this radius 3959 extending spherically outward to, your optical limit. And then we start to use celestial navigation angles, and we see that, we can use angles within a certain threshold, and that's where we go with that logarithmic expression. Which, by the way, when we went through the math and just mathed it out right here, you can see that you get, depending on, how you compare it, optical with apparent with what it would actually be, you get different relationships, and actually you get all sorts of relationships. You can say you get spherical, you get linear, certainly, that called it the globular linear portion. You also get logarithmic, you get parabolic, and you get exponential. So part of deriving the 3959 spherical radius as part of your optical visual limit through the Rayleigh criterion and angular resolution limit is that we can also use it for let's see, when we do the refraction tables, when we're applying optics, right? It also has a logarithmic parabolic scale for the refraction as it approaches altitude. So we have the same sort of mathematical relationship with the refraction indices that we're using for, say, our optics when we're comparing things on the horizon. Very much does a logarithmic expression work when you're approaching on the horizon for things that scale, say, into infinity, or would just compress into nothing on the horizon. All right, that's not linear. You're not taking that linear distance and applying 69 miles per degree when it's 90 degrees on your horizon. It doesn't work linearly for the first couple degrees. Matter of fact, not until it's at 15 or 20 degrees does it work linearly, or exactly where you're allowed to use it, right? Exactly where you're allowed to use this logarithmic expression for the linear portion of celestial navigation on a sphere. Part of the hopes about getting linearly scaled distance for infinite, right?
Okay, let's make sure again everyone gets it. So, if we have a stick figure standing somewhere, we have equidistant limit to how far we can see. Okay, so that would make a little dome. You have an equal distance out in front of you, up above you, etc. You have a little dome, right? What they did was they took the linear portion of this limit and they isolated that portion, which is around 15 to 70 degrees. And they claim that we're seeing in these perfect straight linear relationship and that the earth is curving underneath us to make the stars drop at that ratio of 69 miles per degree or 60 nautical miles per degree. But if you get below that, it falls apart. They just isolated part of our visual limit and then left out the rest of it and claimed the earth was a globe with that little isolated portion of it. And if you go to look at their celestial navigation charts, they say that's the only part you can use reliably. It's the only part that works. So what he's saying is, for example, if you go down below the equator and can see Polaris, right? They can't explain that with this linear relationship. They can't even explain it below 15 degrees. But in our understanding, which is that you have curved visual space and you have a limit, you can perfectly explain it.
Right, so the linear function breaks down at that point. We had Ruhiv go through the exercise earlier. So when y'all go to him for help, he probably needs a little bit more time. But the linear expression definitely goes negative, which, mathematically when you're describing distance is no good. That's not going to describe anything. However, if it approaches near infinity with ever getting there, then that would describe perfectly something compressing into the horizon unresolvable.
Yep. So like, so everyone gets the base premise, right? That like you have so if you're standing somewhere, you have an equidistant, so an equal distance that you can see in all directions. And so if you turn around with that equal distance limit, then you're going to have a dome. You're going to have a circle around you, right? Like if you can see a certain distance ahead of you and you turn to your left and to your left and go all the way in a circle, you're just going to have a circle with a radius because you can only see so far in each direction. That would continue as you look up and go to the zenith above you. So you would get a dome.
Yep.
I don't know if I want to pull out the fact that they have to accept that and they have no choice yet. But so I don't know. Is anyone not following?
I mean, I've given you my opposition to this dome thing before, so.
Go ahead.
If it's a dome, we wouldn't be able to see things outside that dome, right? You're saying we can't see anything outside the dome.
No, that's
so
wrong.
If we put,
sorry, go ahead.
Oh, we can see outside. Oh, we can see outside the dome.
Well, yeah, I do think it's a good point to talk about. That's something that Glober said. Well, go ahead if you want to like clarify what you're saying.
I mean, you know my position of this. If you put something at, I don't know, let's say you can see 10 miles away and you put a skyscraper there. Like I can see the top of this. I should be able to see the top of the sky. You can still see the top of the skyscraper even though it's outside of the dome. Right? I told you about this before.
What?
Let's use the sun for an example so everyone knows. Like basically, for example, what Roof is trying to say is like, well, then how can we see the sun if it's further than that? So visualize like a dome, like you have a plastic dome, okay, and then you say that the dome is like a foot in diameter. You just have a little plastic dome, and then you shine a light from like 10 feet away. So if the dome represents how far we can see, it's like, well, then we wouldn't see the light or the sun, right? Because it's outside of how far away we can see. But that's incorrect. Just like in the demonstration, what you'll see is an apparent light source on the edge of the dome, right? So the light will be coming to you from the source, and you just don't pick it up until it gets within your visual limit, your dome. So you can see certainly light outside of your limit, right? But you don't pick it up until it gets within it. So if I took the light and I shined it on that dome, if I'm inside the dome, I'm going to see a secondary apparent location of the light source on the dome. And if I was to move the light source in a straight line over my head, in the dome, it's going to look like it's arcing up from the horizon back down to the other horizon, which is literally what we see in reality, right? We see the sun pop up from the horizon, arc up through the sky, and come back down. On a flat Earth, it's actually moving in like a circle over our head. But since we only see it from a certain distance away in our little dome, then we're going to see it in an apparent location that is arcing.
Yeah, Witsit. I think I understand a little bit, but I missed the first part. I always thought there's no way there could be a linear function, like a linear relationship, when you're backing up from Polaris because you're falling behind the ball exponentially. It never made sense to me that it could be linear. Is that something to do with what you're talking about?
It's logarithmic. We're in curve visual space. Shane, break it down one more time. You say it in here. I don't want to. This is Shane's point. He did the work, so.
Yeah, right. So they always say it's linear, right? But linear doesn't really work, or it works to a certain extent. It works like in the middle range of your view. It works like above 20 or 15 degrees and not above 70 degrees. So between 15 and 70, yeah, you could say it's linear. But other than that, it's actually like logarithmic, which has like, portions of other geometry, actually like hyperbolic, parabolic, etc. But we'll just say it's logarithmic for now, and it most closely mirrors linear. And they've only limited your use of this logarithmic expression to the linear portion specifically. So like
right. So
yeah.
Good.
Like if you're only using this linearly, you would never know it wasn't a linear expression, right? So if you had to use it beyond this range, they give you correction tables, and then they have you assume infinitely that linear distance scales as far as you can see, because they need you to believe that for other stuff.
So do you
But
get what he's saying? Like, there's just a small portion
Wow.
of it that can be treated as linear that works. If you go look at their
Yeah.
actual tables, they say you can't use below 15 degrees or over 70 degrees.
and
Dude,
even
I freaking knew it, man. I knew it.
yeah,
I knew.
even the part within the linear scale is only linear on paper. Like if you go actually take the measurements within that scale, it's never exact, right? It's whether it's human error or just conditions or whatever. But that is the part where it's most accurate, and they call it linear.
Well, dude, the way they got it is like sky miles, right? They're like, yeah, so 60 nautical miles per degree times 90 degrees of latitude gives you 5,400 nautical miles times 4, which would be like 2,400 nautical miles divided by 360 gives you 60 nautical miles. All right, it's a circle. We got it. Then you're like, all right, but for statute miles, it goes 69 miles per 90 degrees gives you something like 6218 divided by times like 4, give you like 24,000 divided by 360 gives you 69 miles per degree. Hey, look, it's still a circle.
Even that would depend on altitude. Like, you know, the radius is bigger the higher you go up. You know, if you take it at that same altitude all the way around the radius, it's a bigger radius. So how are they standardizing that too? I might be thinking wrong about that, but it sure is strange that altitude isn't taken into account.
It's funny, Rakia, that you say that, because I took elevation angles to Polaris from where I live, and it didn't match up for my area. Like the angle that I got, it was
No,
off. It was actually inverted from the 90, which is weird.
it
How
never
far is
matches.
Polaris in your sky?
What was
Are
that?
you sure you had Polaris?
How low is Polaris in your sky?
I think it's supposed to be like 45 or something, or 40. I was getting, I can't remember, but it was like it was like the complementary angle I was getting from the 90. So it was like 55 or something. But I live in Pennsylvania, so we could figure that out. But yeah, I'm not 100% sure now. I did this like a year ago.
So why wouldn't the ratio work above 70 degrees on a sphere?
Why wouldn't
That's what I want to know.
that linear function apply linearly everywhere, as you guys think it does?
Yeah, but certainly over 70 degrees, you can try to just like invoke your God refraction towards the horizon, but like, what about above 70 degrees?
Yeah, that's a great point.
Do you see that it actually works better on a flat Earth? Is he cutting out for anyone else?
Yeah, bro.
Okay, let me reiterate this point. I think this is the most important point to understand. As flat earthers were saying, perspective causes things to compress down the distance. So if you see a plane fly towards you in the sky, it's going to look like it's going up, and then it's going to get to your overhead, and then it's going to go the other way behind you, and it's going to look like it's going down. If you look down a long street of streetlights, the streetlights, although they're all the same equal height above the ground, they're going to look like they're going down. The ground's going to look like it's going up. If you took railroad tracks and flipped them on their side, they're going to look like they're converging together. If you stand down a long hallway, the ceiling and comes down and the ground comes up. We see that in reality, perspective causes things to converge down to the horizon, right? So things above us optically go down. In all scenarios in reality, we're saying, yes, it happens in all scenarios in reality, including with the sky. The globe says, yes, it happens in all situations in reality, except for the stars.
Mostly because
So
they
it's
don't
just
have
special
angular
pleading.
size, so it would be
It's
hard for them
special
to
pleading.
shrink.
Just special. We're not talking about angular size. We're talking about displacement. Angular displacement. It's just special pleading.
And
Do the
no,
Gloobers
Globe
know what special
doesn't
pleading
say
is?
it doesn't. Globe doesn't say it doesn't apply to the sky. Globe says they're too far away for us to notice that effect.
Yeah. So do
Yeah,
you know what
Polaris
special
shouldn't.
pleading is?
Yeah, Polaris shouldn't sit over a flat plane at the equator due to perspective.
Oh my God, bro.
Oh my
Oh
god.
my God. So, okay, I'm just going to state a fact again, okay? The flat earth is saying that the perspective that causes everything to come down to the convergence point in reality also causes the stars to do that. You guys are claiming, yes, it happens with everything in reality, but not with the stars. Then you invoke an infinite distance to the stars and claim that all the stars are at the same distance to try to justify that perspective doesn't affect how we see them. Then you turn around and claim that they're trillions of miles separated in distance.
Funny how many things are different on Earth than in space there, huh? In their model.
So this is just a fact. Using Occam's razor, flat Earth wins. Yeah, that's correct. Flat Earth wins using Occam's razor. You have to use special pleading and make many assumptions to try to explain yet again another illusion. Another
Funny thing about
illusion, which is
Occam's razor.
that there's an illusion. I don't need you to tell me about Occam's razor. There's another
No, I was gonna say,
illusion
the funny thing
about
about
how
Occam's
stars.
razor is it needs an answer for you to apply it. You can't apply Occam's razor to a
So I'm going to
non-answer.
finish what I was saying. Thank you, man. So this is once again the globe claim is that there's an illusion taking place that just tricks you, and the illusion is that the stars match what. The illusion is that the stars match what perspective does with everything else, but actually it's not because of perspective with the stars. It's because the Earth is curving underneath you.
It's a lot of
It's just an
illusions with
illusion.
Helio. So they're like they're magicians. Weird.
You're wrong about everything.
Oh,
Nice, very substantive rebuttal, man. You
crushed
just
it.
started.
You're just wrong,
Are
man.
you, are you are you saying that NASA's wrong when they describe the very similar effect with their compressed dome and then looking about specifically celestial bodies and the moon or
I don't know. I
Yeah,
haven't
is
looked
NASA
into
wrong?
that. Whatever it
Oh, so
is.
then what are you talking about?
Yeah, I don't have a rebuttal,
You're
but
wrong
I'm gonna
about the
tell you
star
you're wrong.
thing.
Yeah, we
You're
get that
wrong
I
quite
don't
a
even
about
lot.
comprehend
Turns
what you're
out,
saying,
actually.
but you're wrong about it.
You're just
Happens a lot.
wrong.
The argument is you're wrong about
It's Craig.
everything.
That is the argument.
That's it. I mean, that's a good argument. I never heard it put
It's
that way.
actually
That's
actually this
because
meme
I
exactly. So just saying.
explained it in
Craig.
great
Hey,
detail.
Finn, can you rebut the
Why
math?
I
Yes or
actually
no?
don't. What math?
The
You
math.
guys do math?
Oh, good
Okay.
one. Yeah, the math's right there in the chat. So since you're saying, can we do math?
What
Can
is the
you do
math?
the
I
math?
don't know. What is this?
Wait,
What is
wait.
this
Can you do math?
snippet? What is it saying?
Can
What is
you
it saying?
do
I
the
don't know what
math?
it is.
Well, it's right there.
I
Why
can
don't you
do a
look
lot
at
of
it?
math. What is this saying? What is it
Go
saying?
do the math then.
Well, why don't you go
What
catch
is
up?
this picture? Can you explain
It's
this
the
picture to me?
it's the
Context.
it's a logarithmic visual space when it explains the declination of stars. So go do the math and tell us what's wrong with it. On a plane, you
The
can.
No, you broke up a little bit there. Could you repeat that?
It's the
Something about a visual
logarithmic
space?
relationship between us and the stars and how we see them. If you want to go show us what's wrong with the math, go to it. Go do the math and tell us what's wrong with it.
I don't know, dude. I think you're trolling because I
All
don't
right,
know,
dude. Why don't
because
you
I'm
just
not
like go
familiar with
away?
that
All right, I'm just gonna mute you.
Yeah,
I'm
go
not
catch up.
familiar with that.
Yeah,
Why don't you
thanks.
go
All right, just
somewhere?
stop talking. We're in the middle of a conversation. You're just trolling. So, I just want to make sure that everyone kind of gets this because it's very smooth what they did, bro. Okay, so we go out, we see that the stars, as we get further away from the stars, they go down. Just like in reality, when you look at streetlights down the street, right? The further away you are, the more they look like they're going down. That's what perspective does. So our position is, yeah, perspective is doing that. When we took elevation angles to Polaris and we got latitude system, it's because we got further and further away from Polaris, right? And so the star kept going down. That's it. They're saying, no, well, yeah, sure, it happens with everything else, but not with the stars. And the only reason the stars look like they're going down is because the Earth is curving. It's that simple. And then what they did was they cherry picked the linear portion of the measurements and said, you can only use this portion so that we can superimpose it on a globe.
It's so ridiculous, man. It never made sense. Like you're backing up from Polaris, falling exponentially more behind the globe, and it's dropping at a linear rate. It just, I don't know. Never made sense to me.
I want to know, why can you not continue to use the linear portion if it's actually a linear relationship on a globe? Why can't we use that everywhere and it work?
Because it's not really linear.
Yeah.
I mean, that's the only real answer, right?
Yeah, of course.
Anyone disagree? Like,
Right? It's kind of one of
linear
those things,
function.
right? When
It's
you
gotta
like
work.
figure it out and it just hits you and like, you know, your stomach, you're like, yep, that's the truth.
Yep.
Guys got me again, right?
But they basically got nothing at this point. It's getting bad, but
The problem is that the everyday person knows what perspective is, or if they don't, you can easily show them and they can get it, right? Like, you can't deny it. So when you hear that we use perspective and how we look at objects in the distance or how we see into the distance, except, right, for when you look at the stars or even the sun and moon, it's a tough sell for them.
Well, I mean, not really. We're saying it's exactly linear in all the same ways you're using it, but also we can explain the extremities with better math more accurately. I don't know. I think it's a pretty easy.
We're superior. We are superior.
So
no, I think he's saying it's a hard sell for them to claim the sky is the exception. Like,
Oh, yeah.
like just
It's a hard sell
mind
for the
you
globe,
that
but not for us.
Right.
yeah, just mind you that we're talking about a group of people that will look at the video or the picture I just dropped and say that those aren't going down because of perspective.
well, there's a fundamental issue, right? Like we don't know what's going on. I mean, we can attribute it to perspective, but I mean, obviously, as soon as you gain some altitude, you're able to see, you know, quite a long ways. You know, once you get out of the heavy layer, the troposphere, so you can see it quite a lot further. And then also, I mean, obviously, you could see, you know, starlight, you know, and however far starlight travels. It's dynamic. It's far more than just, you know, just perspective, it would seem.
What? Okay. Like with the streetlights in the chat here, the streetlights look like they're going down because of perspective. So anytime we're making an observation, perspective is going to affect our observation. The globe is claiming, sure, that's true in all scenarios except for with the stars because they're so far away, trust me, that perspective doesn't make them look like they're going down, right? Just trust me, special pleading, making making an exception to a universal principle, right? Without like valid justification. And they say, okay, and we're going to actually treat all the stars as if they're at infinite distances and that they're all at the same distance. Then they turn around and claim that all the stars are at vastly different distances. So, and the point Shane's making is, in order to believe that on the globe, you what you have to do is you have to assume perspective is Euclidean, which is debunked with railroad tracks, but you have to assume that perspective is Euclidean, so that we see in straight lines, that we see infinitely in straight lines, effectively, and that there's a linear relationship between us and the sky because the Earth is curving. But in order to make that claim and claim it works, they actually have to cherry pick out a section of the elevation angles from 15 to 70 degrees, and they have to ignore the rest because it doesn't work. But if their claim is true and the stars are actually not affected by perspective and they only change based on the Earth curving, then that linear relationship would be at all angles. Unless suddenly when you turn your sextant up above 70 degrees, all of a sudden the Earth's not a sphere anymore.
I have no idea. I've never done any of it. I was just thinking on the, you know,
Do you see what we're saying though? You see what we're saying though? Like, I want to find a way that everyone understands what we're saying.
I understand.
This is a big deal because just like everything, they claim that something's impossible on a flat Earth improves the globe. We then go thoroughly look into it. We find out, well, not only is that not true, it does work on a flat Earth. It actually disproves the globe.
And it's all like a shady like way they got there too. Like we figure it out and it's like, wow, like they really worked on this, you know?
Remember, guys, the Earth is such a massive sphere that it's flat everywhere.
But that's the best part, right? Like we can use the real formula, and in doing so, show you that we're using their formula, but not limiting you to the range and showing you what happens at the extremities. Like, hey, look what it is really, guys. Look behind the curtain.
So basically, yeah,
So-
where the formula works in reality, we're saying, yeah, it works in reality there. And then we have a superior formula that continues to work in reality at all locations, where their formula only works in a small little portion of reality. That means that objectively the flat Earth position is superior and has superior explanatory power. That's what that means.
It also means we took one of the proofs against us and scooped it up for one of our nice tenets of reality now.
Yeah, how many times have we done that now?
I think every time, honestly.
Yeah.
And all we
Great
own
point.
all the subjects now. Change and scooped up the last one.
Pretty much. Yeah, I mean,
We
what else is
dunked it
there?
in the flat Earth basket.
Yeah.
Well, I think it's time for y'all to get the nav maps out and do your elevation angles and find yourself a fix on a map and show us how it works.
Hell yeah,
It's time
brother.
for us
It's
to
time
get
for you to
Nobel
not understand the
Prizes.
celestial sphere again.
Left lane. If the maps change accuracy based on how they're measured, wouldn't I have to apply it unilaterally to how I take the measurement celestially? So in other words, if I have a meter versus a centimeter measurement for a map and I do an angle elevation, how does that correlate to be equal?
Yeah, I don't know. I know they work now though. Is one
They
thing.
don't work 100%. Both formulas, whether you use Euclidean or non-Euclidean, they're not 100% accurate, either one of them. And that's because
Well, you could make the non-Euclidean 100% accurate because you have
what I'm
huge
saying
free
is
range.
that we're measuring an optical illusion to an angle of something that appears to be in a position. So if it appears to be in a position, meaning it's not in an actual position, but we still get an angle to it, well, then it's not going to be really 100% accurate now, is it? Because we're measuring an optical illusion. Does it function? Does it provide a distance and a position? For sure, but you'd have to keep adding calculation after calculation after calculation to compensate for that particular situation, whether it's the map and how the map's measured, or what instrument you're using to measure the angle. Right? Those are the variables that create the errors. And from what I've researched, you can get pretty good with a sextant up to a mile, but again, you're still going to be off a mile. Now, we have computers and algorithms and calculations to compensate for those errors, but for the average individual, you can navigate just using Euclidean without assuming a spherical Earth.
Just to make sure that we're all on the same page here, like when it's said that is it functional in reality? Sure. We're saying it's not. The globe celestial navigation is not functional in reality. You can't use it over 70 degrees and below 15 degrees. So that means flat Earth wins. We can use it over 70 degrees. We
Well,
can use
do
it
it.
below 15 degrees.
Well, do it. That's what I'm saying. Get the mouse out and show how it works.
Well, there's already
They just say you're
videos
wrong.
online. There's already enough videos
I just
online
debunked you.
from instructors that will show you basic.
Well, all right, dude, but dude, if I can project a thing into 200 equilateral globular coordinate systems with no freaking distance change in between from equal area to equal altitude to everything, then literally it means no difference. Which globular coordinate projection system did you want me to plot it on? Is that really the fucking point?
No, I want to see you actually implement these
Make
postulates that you've got. Implement them. Show us how it works in reality.
Dude, if you understood the
What are maps
math was
based on?
equally valid, you wouldn't ask a question like that.
Well, what are we going to do with all this new information then?
Well, this would be
We're gonna watch the Glober squirm for months and pretend that it didn't happen, and then just deny it, and then I'll come up with new ad homs, and then come up with new fallacious script to repeat it and hand wave dismiss it after they ignore it for 6 months roughly.
Dude, this is our
Or you can
newest kinematic equivalent. So it must be our specialty, I think.
Or you can become a flat earther, Left Lane.
He already
Who?
is. You just don't know it.
But
You
I
got
just gotta
lots of
repeat this. I
options.
gotta repeat this. Left lane. If the globe Earth celestial navigation method can't be used reliably above 70 degrees and below 15 degrees, but if you use a flat Earth method, you can use it above and below that threshold. Which one would be superior?
Well, check it out and show me that's a fact.
I just asked you a simple question.
I don't think it's true with it. I don't think that flat Earth can use triangulation and celestial navigation and find a fix on a map.
Which one would be more superior, Left Lane?
I don't think that the flat Earth math, the triangulation, can do it at any point on the map, at any degree.
Oh my God. Will you listen to anything that we were talking about?
No, it's
Could
not
you
even
still man what we're talking about? So you're super confident it wouldn't work, but you can't even recap what we're talking about.
I'm going to give Left Lane a situation he can draw for himself, or maybe if he knows how to 3D model. If you took a sphere and put 3 mountain peaks that were equal height to them, you could triangulate using Euclidean between those 3 mountain peaks, regardless of it being a sphere. Do you understand that, Left Lane?
Sure.
Okay, there you go.
Well, I mean, like we do.
But
Like,
wait,
like
Steelman,
if
can you
we
Steelman
can't,
what we were talking about? For
dude,
real?
I can project any result into any coordinate system imaginable. Left Lane, 200 different projections on whatever I want to choose. Today, for fun, I took apart the whole eclipse cycle, did that in a pivot table, and projected that just the same, right? So I don't understand with longitude and lat when I say you can do anything and it doesn't matter why you insist on a particular globular coordinate system. But if you like, we can do it on 200 equal coordinate systems.
No, I'm just saying, what is the significance of all this? How can we benefit from it? What is the utility of it? And if the celestial navigation is incorrect, then you can demonstrate how it's incorrect on a map and finding a fix.
No, they've already demonstrated that it's incorrect by putting in their own manuals that you can't use it over and below certain degrees.
Yeah, that's news to me. I haven't heard that.
Well, now you know, man.
Why do people think that if you're flat Earth you can't predict eclipse?
Well, I don't
Isn't
know.
the Mayan calendar a flat Earth calendar?
Oh no, I pretty much put that to bed with a video earlier. I think a nice 9-minute expose on everything about that.
Yeah,
Their
it's just
talking
for
point is like, oh, they can't. We can still man it, right? Like, oh, but they couldn't predict the path of totality or what
Oh
time
no, I
or
can.
what location.
Yeah, no, but we can, right? The day
Oh
just
yeah, I know,
project the shit up. Fine. That's why I did exactly that. From
Yeah,
took it easy.
and I mean,
Oh, by
well,
the way,
that's
thanks,
all.
Fred.
That's also because they used simplistic. So I don't know if a lot of people know this, right? So if you go to school, you learn these complex formulas, and out in the real world, those complex formulas are rarely used by the layman, by us people who do trades. We do things the long way. We still do things kind of old school way, where we'll pick up a board and we'll hold it up to something, we'll scribe our marks, etc. Now, there's formulas that have been developed over the years that would expedite that entire thing if you knew how to use the formulas, but very few people actually do. In fact, really only senior level management on very big jobs where engineers are sitting down doing the formulas. Because out in the world, there's either multi-million-dollar systems that do it that way, or 4 or 5 guys get together. We still kind of do things the old school way, where we hold up sticks and scribe, and that's just kind of the way it is. And it's funny because the Mayans probably used a very construction world type approach to their their predictions, but you can take the very same thing and fill it in with the modern mathematical formulas and get a whole lot more accurate based on their own observations, which they believe the earth was flat.
Yeah, do you want like a 60-minute summary real quick?
I mean, I got all day, so
60,
you take
60
time.
seconds, right? No. You got a solar cycle, you got a lunar cycle, you got a 15-year solar cycle, you got an 18-year oscillating lunar cycle, 10 months, 11 months, right? Keep switching. When those oscillate between, you get this intersection period of 351 years. Within that period, you have intersecting periods of 70 eclipses. When you have one pair of eclipses, you can predict the other pair, right? When you have an oscillating pair, then you can predict the next pair. When you have two 351 to 352 year periods, you have one 651 year astronomical year, which actually contains within it every precession of every body that it will ever make. And then with that knowledge, you can predict that in perpetuity. How long was that?
40 seconds, maybe.
There you go.
That was awesome.
That's a good word by
You can't escape the sexy decimal system, and that's where it's all derived from. All of those predictions.
Yes, but like I did that because like on Twitter because they were like, no, use the globe model to predict it. The point is, there's none of them are predictions. It's all predictions once you know the cycle. It's got nothing to do
Yeah.
with like gravity, Newtonian physics, any of that shit.
Yeah, and feel free to stop jumping in if you're just gonna like not say anything of value, please. We get your coping, and you have to convince yourself that we're wrong about everything, but we don't need the color commentary, my brother.
Yeah, dude, eclipses
So they don't
were
have
just for fun.
eclipses.
Yeah, that was just for fun.
Yeah. So they don't have eclipses. They don't have celestial navigation. They don't have GPS. They don't have satellites. They don't have, hijacking the long distance theodolite measurements outside of their accuracy. They don't have spherical excess. They don't have gravity. They don't have astronomical explanation. They don't have any exclusivity with the Earth, with the solar system model or with their universe model. Like, they don't have rotation. They don't have the pendulum. They don't have the ring laser gyro. What do you have? And how do you sit here and convince yourself you still have all those things? What is going on in your brain?
Yeah, I don't get it.
Every single one of those things has not only been rebutted, it's been taken away from the globe model and proven to not work or be viable. And people are able to sit there and pretend that didn't happen and still hold on to each one as if it wasn't refuted. I don't know. It's crazy to me.
I think that's why they don't listen when we talk about stuff like this, because they don't want to know for sure. They want to be able to hold on to the fact that we messed up or, we did something wrong. They want to be able to hold on to that, because if they really listened and really truly understood it, then they would have to face themselves and ask.
And proof of that
themselves
is that
those
they can
questions.
never actually stillman what you said.
Well, yeah,
Oh,
like,
of course.
do you know how I know none of them really ever care to want to know? Because all the times they make fun of Gleason's map, no one ever read Gleason's book. And guess where I learned how to predict freaking eclipses and use the solar cycle? Hey, Gleason. Wonderful chapter on his book. He has all that information in there. You guys should go read it.
Yeah, man. But what I'm saying is, you're right. They have to, they don't actually hear what we're saying. They just think in their mind, these people are wrong about all this somehow, or I'll wait until someone I trust summarizes their point for me and tells me why they're wrong. So what they do is they never hear the point coming from us, our actual point. They go listen to someone else straw man our point and then claim it's wrong. And then they just stay asleep. So they're confident we're wrong about all this, but they couldn't stillman it. Finn, can you stillman our argument? You keep jumping up. Can you stillman our argument?
Which argument? The one about the stars disappearing into the horizon?
Yep.
Yeah, I can. I did try to steelman it. So basically, assuming that the Earth is not moving relative to the stars, we should see if we could let's say the Earth isn't moving relative to the stars, and that there's some other phenomenon that is causing the stars to drop. Let's say, let's say the stars, they aren't moving like the way we would expect them to. They aren't moving over past the sky. Then first of all, why do we observe them move at all? Why do we observe them move at all if we try to time lapse the sky at night? And
You
why
see how
do
you're
we
not
observe
stillmanning?
them
You're
all
not
move?
stillmanning our position. You can't even say the stillman out loud. You have to just start trying to pretend something's wrong with it. You don't even know what stillmanning is. You're supposed to be presenting the
I know what
strongest form of
steelmanning
the
is.
argument. No, you're
It's very hard to present a strong form of your argument. It's a weak argument. I'm trying my best.
But I'm proving that you can't say it's a weak argument because you don't even understand it. It has nothing to do with if the Earth is moving or not. Literally nothing to do with
I
that at
know.
all.
I know what you're saying. You're saying that if
No,
the
you don't know what we're
distance of
saying.
the stars, I know what it is. The distance of an object It is slightly above the observer. As it increases in distance, let's say horizontal distance, it does appear to move towards the ground or at level with the observer's eye. That is your point.
Then why were you talking about the Earth moving?
Because I was trying to steelman your argument. I was trying my best. It's very hard to build a stronger version of your argument.
It had nothing to
But
do
it's
with the Earth
hard
moving.
because it's not possible.
You weren't
No, the
still
arc
manning our
moving
argument. It
would
has nothing to
complicate
do
it.
with the.
The arc moving
Listen,
would
dude.
the arc moving would complicate it.
It has nothing to do with the Earth moving. So either the Earth is moving and it makes the sky look like it's moving, or the sky is moving,
Relative.
which is why. Okay, so that has nothing to do with what we're talking about, which is how the stars change position in the sky as we move on the Earth. That has nothing to do with the Earth moving whatsoever. You still can't stillman it. So try again.
Relative motion.
Stillman the curved visual space of the azimuthal grid of vision that explains the 60
I don't
nautical
know this
miles per
term. I
degree
don't know what is
relationship.
azimuth. I don't
Dude,
know
Speak
any
up
of these
this
terms.
time.
Finn, you're interrupting me, and that's why you don't know how to stillman it. So I'm asking you a question, and then
Because
you
it's
have
not
as long as you
possible.
want to. Buddy, listen. Stillman the argument that we just made. So I'm not asking you to come up with an argument. I'm asking you to stillman the argument that we just made, explaining the 60 nautical miles per degree on a flat Earth.
Okay, you're saying that what are you saying? What is the thing about 60 nautical miles per degree? I understood part what you're saying about perspective, about your argument about why we should see things move towards the horizon, and I like agree halfway with that, but I don't agree with the whole argument. But I don't know the specifics of this 16 nautical miles thing. How does it work?
Right. Right. So when you were jumping in saying that I was quote unquote wrong about everything,
Just wrong.
and you jumped in like 3 times and said our argument is just wrong, that was clearly just nonsense because you've now admitted you don't even know what the argument is, right?
And that you half agree.
I know one of your arguments. You made more than one argument.
No. When we talked
But you're
about
all
this
wrong.
specific part, when we specifically talked about the 60 nautical miles per degree, you said that was all wrong, and you can't even explain it. So you're just proving our point, which is that you guys sit in here and you don't actually listen and understand what we're saying, but then you have this like illusory confidence to step in and tell us how wrong it is, but you don't even know what it is. How's that not weird?
I explained how one of your arguments was wrong, but I still hold by the position that they all are, even though I haven't debunked all of them.
You didn't explain how one of our arguments is wrong because you started talking about the Earth moving, which we're not even talking about.
Can I
He's trying to
interject for a
steal that.
second? I just want to clear something up. I'm sorry. What argument is he trying to straw man? Because I'm still trying to wait for it.
I was trying to
He's
steal
trying to
man.
still man the argument we just made about how you can
Not that one, a
explain
different
the
one.
60 nautical miles per degree relationship on a flat Earth. They claim that the fact that there's 60 nautical miles per degree relationship proves the Earth's the globe. It doesn't work on the flat Earth because it's a linear relationship, and it wouldn't be like that on a flat Earth, and it's impossible. We have now ripped that away from them.
Does he understand that even in the information, 1 arc minute is not 1 exact nautical mile? Does he understand that even in their own math, it's 1.008 nautical miles per 1 arc minute? Do you understand that? So meaning it's not a precise 60 nautical miles, therefore a sphere.
Well, that would be so what?
Doesn't matter. Doesn't matter though. Like, even if we act like it's good enough relationship to use it, it's close enough. They say it doesn't work on a flat Earth because it's linear. They're incorrect. You can explain it on a flat Earth. And I want him to admit that he doesn't know what the argument is. So when you said
No,
that
he
it was
doesn't know.
wrong,
He doesn't know what's going on at all. He's like, I don't know what's going on, but something's going on, and I think you're wrong. He doesn't even know what his name is. He doesn't know what's going on.
he said you
We
know
just
you're
want to
wrong.
steal
All he
man.
has to do is to understand that to get an elevation angle and then move a set distance, get another elevation angle. Understanding a circle is 360 degrees, he should be able to understand that you can invert both. You can invert it as a sphere or invert it as a circle with an elevation angle. You can do both.
So actually, like,
He has to understand that first. So at least show them that it's applicable in both models. It's just one
We
is
have.
inverted.
We
Okay.
just showed him that. We showed him that with pictures and everything.
Also,
Like,
well, we're at it in Excel. It's just a matter of a
Just some-
translation of 90 radians, right? It's a super easy translation. It's just so we can point out flat, like flat to globe is like 90 radians, right? Just saying.
Ben, it's just obvious to the room you don't actually understand it. So, like, it's fine, but, like, stop pretending you know we're wrong about it. Like, it's just weird. You're just coping.
Once he understands that both are applicable, it's just a matter of interpretation, then he has no argument.
But and then there's actually a cherry on top of that. Is like, yeah, but in fact, with the Earth being flat and you having a curved visual limit, it works better because that can be applied at all degrees. At the horizon, all the way up to the
less
zenith.
assumptions and less mathematics. Sure, yeah.
And it has more applicability because in the globe they say you can only use the angle measurements, the elevation angle measurements between 15 and 70 degrees. Because that's the linear portion. It's relatively linear. And then they ignore the rest, but if the globe was correct, it would be linear the whole way.
But that's just to compensate for obviously error due to the the limited scale of what you're doing the measurement, right?
No. Like we have like an error even within the 15 to 70 degrees, right? And it's not exactly 69 miles per degree. And
Of course, because if you look, like, again, this is the argument with instrument and measuring the elevation or inclination. Your instrument is only going to give you the precision of your instrument is what you're relying on for the inclination or elevation, whatever you want. So if you're using your human eye versus another instrument, you're not going to end up with the same exact angle. They vary based on the observation and how the observation is made. So if you're using optics, just the human eye, you're probably not going to end up with as an accurate of an angle if you were to use an inclinometer.
But it is accurate enough to use it on the Earth and navigate with relative accuracy.
Yes, it's what they use for the first order. So if it was inaccurate, they wouldn't use it for the first order measurements. It's the second and third order, which is done with added logarithms or model, adding a model calculation to it. So that's what we use as first order measurements, which is all Euclidean, because it's the easiest, most accurate way that we can devise a measurement.
And we're pointing out that it actually isn't all linear. And it's logarithmic, and it works on a plane Earth better because on a globe Earth, it has to be linear the entire way. And so not only were they wrong when they said you can't explain 60 nautical miles per degree on a flat Earth, it is explained better on a flat Earth. And it's not a strictly linear relationship the whole way up, which is what that's easily proven because their own tables say, oh yeah, but obviously once you get below 15 degrees, that linear relationship actually falls apart. It's not going to work. And as you get above 70 degrees, it's not going to work either. So you can only take your measurements between that window. So there is really no debate here. The globe model manuals actually say the same thing we're saying, right? But if the Earth's actually a globe and we're actually seeing infinite straight lines and Euclidean geometry and the stars are infinite distance away, then there would be a linear relationship from the ground all the way up to zenith and all the way back down. It'd be the same the whole way. It'd be linear the whole way.
Do they give a reason why it doesn't work above 70?
I haven't heard one. Shane, have you heard one?
No, like refraction, nonsense, lateral corrections, altitude corrections, all sorts of corrections. So, like, actually, hold on. I think I wrote down with their actual description.
It's only 20 degrees.
Refraction doesn't make sense, right?
No, refraction
No, it
works
doesn't.
below it, right? Towards the horizon, but like, how's that going to explain up above?
So, here, ready?
But
I thought this might
who
come
is
up
it-
by copy.
Who's within 20 degrees of the pole anyway?
Here's where it fails in both models.
It's
though.
almost like I was prepared.
This is to be genuine where it fails in both models. The land isn't consistently doing anything that's regarding our geometry. It has undulations that obviously interfere with the distance traveled. So you can only have approximations using whether it's the Haversine or whether it's using Euclidean. They're not 100% accurate either one. So that should tell you something.
Well, of course they're not, because like we don't live in a perfectly flat or perfectly spherical world, bro. But like,
That's what I'm saying. So the argument is sort of moot because you can't back either one because the undulations of the land are interfering with the actual distances, right? So
No,
Leflander
you can
said
no. You can still support. You can give supportive evidence of the overall geometry, even with the undulations within that, right? Like their whole argument is that since the Earth's curving at a certain rate, generally, right? Because of course there's difference in topography that like you can know where the stars are going to be in relation to how far you're moving on the globe, and you can navigate using that, and that proves that it's a globe. But they actually can't do that. It was a whole facade. They can't even use the measurements below 15 degrees or above 70 degrees. It doesn't work. It doesn't work, which proves that that whole claim that they've talked about for years about how, oh, the linear relationship of 60 nautical miles per degree works everywhere. It works all the time. It proves that the Earth's a globe. It can only work on the globe. That was objectively wrong. And none of them are going to admit it. They're all going to pretend they don't understand what we're saying. They're going to ignore this argument for probably 6 or 7 months until someone like MC Toon comes and gives them a new script to say.
Yeah, but what would be the reason for this above 70 degree thing? That we see too well when it's at our zenith, and
That's
we
a,
got to
that's a
get
good
that
question.
fuzzy averageness. That's strange.
I've
I don't know,
never
but
heard,
Left
I
Lane
never heard
just
above
said
the 70.
who lives within 20 degrees of the pole anyway.
I've
Like
never
that
heard of
has
above
anything
the
to do with the
70.
math.
I've never, out of all my research, I've never seen above 70 as an issue, but definitely below 15.
From my understanding, that's what Bacon openly said to Shane. Is that correct?
Yep. If I'm looking right now, it says
I've
70.
never read that as a stipulation into measuring anything when it comes with if you're doing the what's it called, when you take the zenith angle and then you measure to the star. I forget it now. Geez, my slip in my brain. You can take that particular calculation and multiply it by 60 nautical miles and get a linear distance to the GP of the star, right? It's a basic calculation, simple calculation.
Yes.
Co-altitude.
So it's co-altitude.
I just called a captain friend of mine that's done celestial navigation. He said that the math, something about the math, he couldn't remember, but also the ease of taking the measurement was one of the reasons that you don't go above
It
because you're
says
angling too high up. Like
he says stars too close to the zenith tend to be ignored. If they're too high, it becomes too hard to make sure you're taking a vertical angle. So one of the recommendations is to pick stars under 70 degrees elevation, which is a bit arbitrary. Some people might recommend 75 or 65, exactly. Yada yada yada. That's essentially where I got it.
Okay, well there you go. And so repeat it
Interesting.
again, though. Why they say it's because it's hard to determine the accuracy of the vertical angle.
True zenith, perhaps, maybe.
Oh, and Amish says because it's not valid because the linear average being too divergent from the logarithmic, right? Which is what we're talking about. And also, yeah, Amish is like hugely involved in this, and so is Viking. The dude is putting together all the visuals because them two have been like working with the collab for like 5 days straight now, I think, since we started. So shout out to them.
The point
Mic
that
check.
he just made is our whole argument, right? Like that's the proof that we're right and they're wrong. If the reason is because the linear becomes progressively divergent from the logarithmic, that is direct evidence that like the globe claim is wrong. It's not just that we can explain it; it's that the globe claim is wrong.
Yeah, it's a double whammy. It's like we got it, and we got it by using the full version of the version that they hid from you.
I wouldn't say it's wrong. I would say the utter conviction claiming that it is wrong, but the guessing or the presupposition is not a wrong thing. It's not illogical to assume that you're living on a sphere,
not
right?
illogical to
It's just
assume.
Wait, time out. Do you understand what we're
make any
saying? Is like, think about this. If I went out on the Earth and I started using this method to do celestial navigation, and I assume the Earth's a globe, so there's a linear relationship between the Earth and the stars, and it's 60 nautical miles per degree. And I start going out to make these measurements, but I can't. I go up above 70 and it stops working, and I go below 15 and it stops working. But then I go out on the Earth and I assume that the Earth is flat, and I assume that it isn't just a linear relationship between the Earth and the sky. It's actually logarithmic. And then I make measurements below 15 degrees and above 7 degrees, and I can accurately navigate even above those degrees. That would prove that the globe claim is wrong because the geometry of a globe would necessitate that it's a linear relationship the entire way.
It's only a linear relationship if they treat it as a cylinder. That's it. Not a globe. It's a cylinder.
Oh, sorry, bro.
Listen, it should be most accurate above 70. Like measuring from your zenith, from your 90, you should be like the most accurate, not the least accurate. That part really is, I don't know, get.
Well, you would think so, yeah. I mean, certainly when it comes to stuff like refraction. I
To
wasn't
have a
even
lin-
fully understanding what
to
you
have
were
a
saying.
linear relationship, they treat it as a cylinder. They cannot have it as a globe and have a linear relationship. So I don't know why you keep saying that. It's a cylinder.
Why?
Because you can only have a linear relationship if it's a cylinder. And just go look. They talk about how they use the model for a cylinder. They tried all kinds of various models, right? That's the thing. You have a first order, which is Euclidean, right? Straight lines and angles, right? If they're going to treat it straight lines and angles, they have to take the surface of the Earth and impose a coordinate. In this case, it's a cylinder coordinate system, which you'll get a linear relationship. But then you'll have refraction errors and so forth. You won't ever have a globe. Now, they have the Haversine formula, which is 20 miles, maybe even 50 miles off, depending. But again, it's assuming a distance
Hey, what's up, Shane?
based on sphericity and not straight lines and angles.
I just don't see the difference between a globe and a cylinder if you're using the curve part of it.
The cylinder is curved, but the only way to get a linear relationship is to have a cylinder. You can't have it on a sphere.
Wait,
I
a
know you keep saying
celestial
it, I'm just
sphere.
wondering.
A
There you go.
celestial sphere wrapped around a regular sphere would give you a linear relationship. You don't agree?
It would, but you're not going to be applying the math in that scale. You're going to be treating it as a cylinder.
This is a smaller scale, though. So, like, but we're talking about from like the meta. Their whole claim is like, I can travel across the whole world, and there's a linear relationship with the celestial sphere and then the Earth being a sphere, and it's 60 nautical miles per degree. And sure, there's slight fluctuations here and there, but that's because the Earth's not a perfect sphere. And so that proves that the Earth is a sphere, right? Like, that's their whole claim, but
it's a
it
reification.
isn't true. What I'm saying is, even beyond the reification, they don't even have the accuracy to reify in the first place or affirm the consequent of, right? So, like,
Oh, they called in Xanax. Look out, everyone.
Oh God, now Xanax here, dude. I might as well go blow my brains out.
no, Xanax, just go do the math before you jump in, please.
To blow my brains.
Pretty funny. What math you want me to do?
There you go.
Okay.
That's it.
Shane, you got it. No, I said your name first. You gonna play like rock, paper, scissors or something?
Oh, you want to like verbally
Tagger it.
explain it again? No, hell no. Xanax, that's like a bunch of reading. There's
Okay,
a database.
I'll
I
do it.
published
I'll
a whole
do it.
bunch through. There's visuals. I wrote a book about it.
I'll
Like,
do it.
come on, man.
Literally,
I'll do it. I'll do it. I'll do it. I'll do it.
It's here. It's published.
You wrote
I'll
up.
do it. I'll do it. I'll do
everywhere,
it. I'll do it. I'll do it. I'll do it real fast. Okay, you can look into the chat. We actually have all the math for you, all the depictions, all the graphs. Okay, so if you're going to contend the math, then go do the math. So if the globe claim is like, oh, we know the Earth's a globe because we can use celestial navigation, and the linear relationship with the Earth and the sky of 60 nautical miles per degree proves that the Earth is in fact a sphere because we can accurately navigate, assuming that linear relationship, and that's the only thing that works, and that it can be a linear relationship on a flat Earth. But in fact, we've discovered that that relationship is logarithmic, and if you understand this logarithmic, you can perfectly explain on a flat Earth, still get the 60 nautical miles per degree. In fact, it's more accurate because you can extend that application above 70 degrees and below 15 degrees when the globe model actually states that with their celestial navigation that you cannot use the measurements outside of that window. So we can't explain the 60 nautical miles per degree relationship because it's logarithmic. The claim that it's exclusively evidence for the globe because of the linear relationship is incorrect.
Please define how it's logarithmic.
What?
What do you mean define?
Please define what you mean when you say it's logarithmic.
Oh
What?
my God.
So I'm not doing this. Like the math is
Yeah,
in the,
dude, don't feed the troll with it. Do not feed the troll.
No,
with
he's
it.
just, he's avoiding the point. He went,
Why
I'm not
do you
playing this
think
game.
it's-
I'm not playing
why
this
do you
game.
think
I'm not
it's
playing this game. I'm not playing this game.
Hold on. Okay. Ready? Apparent distance to actual distance is a logarithmic relationship between degrees and miles.
Apparent distance to what distance?
Actual distance.
What does that mean?
Well, I mean, if you look through the math, right, and use unit circle to approximate a fucking unit sphere and use that like hypotenuse at 3959, like I said originally, and then use basic trig to approximate sine and cosine for the length and the height to get the GP and the fucking distance, other thing. And then you repeatedly do that at each latitude all the way through to, approximate the different degrees of elevation all the way through the latitude, and that's what you get when you have the linear relationship of, the 6210 miles linear relationship ends up being the linear expression of the geodesic arc of 3959 for the spherical radius. Just to
got
catch you up.
fucking murked, bro. You just got murked.
That was about as clear as mud.
Yeah, but I didn't.
Okay, see, just stop talking then, Zanuck. We get that you're not capable
I
of
heard what you
responding.
said. The apparent distance and the apparent angles, and then the trigonometric relationship between those heights over distances,
All right,
etc.
buddy.
And then you said it went into a logarithmic realm that I don't quite understand what you
Oh,
mean.
you're just totally butchering. You don't
I wish
understand it.
you would just explain to me in simple terms. If you understand something well, you should be able to explain it in simple terms. I can.
Yeah, we don't see
what
a
is the
perfect
what is
Euclidean
what is the
geometry with a
logarithmic
linear.
relationship?
Oh, please explain it to me so I can talk through you.
Was actually
Like, what's
asking a
wrong with
question.
you?
You just start. That was you.
You're
It's you
asking him to
explaining.
explain
Go
it,
ahead.
and then you keep
Stop.
talking, bro.
I had to
Just
ask
stop,
what you
man.
explain.
And then he
I
still
said,
talks.
please
bro.
explain this, and then okay, I'm not going to say a word. Go ahead.
Okay, so the globe assumes that we see in straight lines in Euclidean geometry, and that we see stars that create a celestial sphere around a physical sphere that gives us a linear relationship. They claim the stars are actually an infinite distance away for intensive purposes. So the only thing that makes them drop in the sky is that the Earth is physically curving. The Globers have then claimed that being able to use that linear relationship of 60 nautical miles per degree, and it accurately works to navigate on the Earth, proves that the Earth is a globe, because that proves the relationship is linear, and that wouldn't be the case if the Earth was flat. We're saying actually that's incorrect, because it isn't a linear relationship in reality, it's logarithmic. And if you actually apply that to a flat Earth, it works perfectly fine. And even more than that, your model says in their navigation manuals that you can't use the elevation angle measurements below 15 degrees or above 70 degrees because they'll be inaccurate, which means that the globe model's claim about celestial navigation is actually the one that's wrong, because basic geometry would necessitate there is a linear relationship the entire way. They cherry pick the portion that they can treat as linear and had to neglect the rest of the measurements that work better on a plane Earth with curved visual space with a logarithmic application on a plane. If you want to check the math, you can. The math's in the chat. Okay, I'm not playing this. Let me try to quiz Austin game to pretend like I know more about something I don't know anything about. I'm not playing a
Really?
game where it's just like I'm just
You've
telling you
already
right
made
now. I'm not doing it.
You've already made several errors
We're
in your
not
statement
doing
there.
your whole little. You Google something for 30 seconds, and then now you're like
I don't
a
Google
master
anything. You know,
over
that
it,
Google
dude.
window's not open in my world, pal.
What
It's
error?
just basic,
Google
simple
Xanax
math.
stuff.
Let's
Google ask
Basic,
Xanax.
simple
Xanax
math.
is the first error.
The reason we don't need to use an elevation angle, and that's true that he says you cherry pick and put things in to support your case based on things that really have no bearing on the actual basis of what we're basically proposing here.
What's
We're
the
saying
first
that
error?
we're not using elevation angles.
First error.
I've never once used an elevation angle. I've
Xanax
said
clown show, bro.
we've done co-altitude angles, which are
What's
different and
error?
don't. So I can't respond.
I'm asking you, what's the first error? You're going to ramble. Let's just focus on the first error. Why do you believe it's an error?
Because if you start using elevation angles and start contending that they're not used based on what you've read in your Google searches, there's an easy solution to that. We don't need to use elevation angle. That's a sextant requirement. We're not talking about using six. We're talking about just using the sky.
So
for
the
purposes
first
of
error,
Can I
is assuming an elevation angle is required. That's the first
No,
error.
it's not. It's not. Look. Let me finish my sentence before you start jumping in. That's the third time.
All
you've
right,
done
I just
go
it.
want to
on,
know what
dude.
the error is.
So I'll tell
He's
you.
trying to steal
Using
me. He's trying to
Okay,
steal me.
finish your point. Okay,
using
Xanax
a 12 altitude
and then
angle.
Platter.
Do you need elevation angle flat data to get a co-altitude angle? Do you need to have an elevation angle for that? Because the ultimate goal is
You
to
need
get
a right
co-altitude
angle
angle.
triangle.
You guys missed the best part.
The
I know this is
co-altitude angle
crazy, man.
is easily obtained by just getting a orientation.
Somebody asked us where
Particular
3959 came from.
What?
Just stop, Zanuck. Okay, go ask Bacon and Ruif if it works, Zanuck. How about that?
If what works?
If what we're talking about works. Because
the
you're just
thing
going to
that-
make yourself look retarded by saying it doesn't work when the people on your own side that are obsessed with celestial navigation immediately conceded that it absolutely does work. It's basic understanding that you could just apply the inverse.
We're very much involved in setting this up, as a matter of fact, just so you know.
Okay. You can do the graphs that Shane, I think you might have put them someone else, of the logarithmic scale of these curved effects of distorted
Oh my
straight
God,
lines
bro.
on a graph. Yes, that
data-
is a logarithmic representation of what you're talking about. But that's not
Thanks.
reality. 'Cause
Thanks,
reality
bud.
is we don't
I
need to go.
appreciate that.
You're a
We
So
don't
then
need
you
to
agree?
have-
You agree that if we see in a like celestial dome, a personal celestial dome of 3959, and it's an equidistant limit in all directions, then there would be a logarithmic relationship to the sky, and that we could use the actual relationship of 60 nautical miles per degree with perfect accuracy on a flat Earth.
Yeah, if you're doing a transformation.
Yay!
No,
Good
you're doing
job.
you're doing a transformation, but we don't see things. We can validate whether that is actually correct with a simple few tests. And
Why do we
those
waste
tests,
our time
those
with you,
tests
bro?
of, for example, having a
already did.
God, I told you how we can validate it and then immediately run over me. You can easily do just looking at a star, like the North Star, and just move along up in the sky. If you're getting close to the northern latitudes, you can then see for every movement you make across the surface, you see a direct linear relationship of the angle with respect to the
He's just
movement.
not very
And that
smart.
doesn't happen.
Let's-
That doesn't happen with any. There's no logarithmic relationship to that at all.
Thanks for
Let's
wasting
do
all of
one
our
test.
time, bro.
Ready?
Let
One
Shane
test.
respond, bro.
Let's do one test. Ready? Polaris, 2 degrees below the equator. Does your linear expression
Didn't I
describe that or
Didn't I
not?
just say we don't do that?
Now you're
I just said we don't-
interrupting, bro. Let Shane finish, dude.
That's it.
Oh, how rich-
That's
how
I
it.
already
rich-
heard
is
your
that?
bullshit, dude.
Dude, does your linear relationship expression work for that observation? Yes or no?
Yes or no?
No,
Absolutely not, right? It goes negative. It's retarded. What a
it's not
logarithmic
retarded.
expression explain that relationship.
It's not retarded because we
Would
we-
a logarithmic explain it? Yes or no?
Yes.
Thank you, sir.
Yeah. So we're not talking about that though. It's
Okay,
like
so-
simple test.
You're done.
We don't find. So we all agree that refraction can bend light. We all agree, right?
Monologue
Nobody
Xanax
gives-
show, bro.
Does
We're not
anybody
talking
agree
about
that light can bend?
refraction. We're not talking about refraction right now. We
But
understand
the
that you're
explanation,
Zanuck,
you
listen,
asked
we
for an
understand that
explanation.
you're.
Is that one
Somebody
possible
mute this
explanation?
guy, please.
We didn't ask for an explanation. When did someone ask for an explanation? Okay, no one did. We
You
asked
asked
about
for
the
the
math.
you asked for the
No, we
observation
didn't.
of you asked for the explanation of Polaris being observed 2 degrees below the equator.
Do
You
you
asked for the
bet
explanation.
$500 that we didn't ask for the explanation? You want to bet $500 on it?
I'll go 1,000.
Okay. So we obviously
Yeah, sure.
already know. Okay, $500. Who's talking?
Sure.
And
Me,
if you
Duncan.
don't pay me, you have to leave the server.
No problem.
Okay, and I'm just going to clarify. You understand the bet? We actually asked him about the math, right? We asked him if the actual linear relationship.
Hold up. Even though it's funny, we're not having moderators bet people money and then have them leave the server. We're not doing that. I know it was funny and it's a joke, but that's just not cool. That's not how we run the server. Nobody's leaving a server because they lost a bet to a moderator. Okay?
It was just a joke.
I know, it's a joke. I get it. But that's just not cool. Yeah. Anyways, can we just keep this a little more clean? I wanted to say before, you guys like evoked Zanuck and then everybody like interrupted and bowled over him. If you're gonna like bring him up, you should at least let him respond. But anyways, carry on. Sorry. Go ahead.
Thank you, Joe.
Okay, so the point was that we aren't asking about the fact that you're going to say that refraction lifted Polaris up below the equator. That wasn't the question. No one asked that. We already know that's what you're going to say. That isn't what this is about at all. It's a red herring tactic for the other guy to jump in and interrupt and say, you asked for the explanation. That's not what happened. It's a tactic to avoid the point. It's about the math. We asked, does the math work on the flat earth? Because you guys have claimed for years it doesn't work on the flat earth. So to start changing the subject to how you can explain why your math doesn't work is irrelevant. So does the math for a logarithmic expression work to explain Polaris 2 degrees below the equator? You said yes. We said, does it work with your linear expression? You said no. Okay, that was the point. We're not talking about refraction.
But if you account for refraction, it does.
We know that you can invoke refraction. That is a non sequitur, bro.
It's not a non sequitur. It's very logical that you bring that up.
Is an explanation for the view of Polaris below 2 degrees below the equator. Can we use refraction as an explanation?
The argument isn't about that we can see below the equator, therefore the Earth's not a ball. No one made that argument. Did anyone make that argument?
No.
But you
To be
did ask
fair-
for an explanation. You said
No, to be fair, I'm not even sure it's possible, right? I'm not even sure that's possible. I'm just saying, hypothetically, to do a test, right? Like a mathematical expression, which we did and didn't need to actually think about it. We just applied math and we determined our conclusion, right? We ended up on the same side, so it's all done.
We're trying to just have an honest conversation about the efficacy of the math. And it's like impossible because we just are constantly bombarded with interruptions and diversions and obfuscation and deflection.
And like, I didn't like invent math, right? We just plotted this out like as it would. We used sine and cosine to approximate like length, right, and height, and then all the way through. What you get when you start describing the relationships inherent already there is all these functions that I keep describing and invoking.
All right, dude, I'm gonna jump in and mod really quick. Let's all take it back a second. Gio's right. Let's not attack each other. Let's not. I mean, I'm guilty of it myself, guys. Like, Zanuck is annoying and stuff, but I gotta leave the emotions at the door. So my bad, Gio.
Dude, I like Zanuck. He immediately was truthful. I didn't really expect that. I was ready for a fight, and he was just like, "Yeah."
But no, he just now said that the linear relationship doesn't work.
Oh.
So what are you talking about? He literally turned around and then double spoke and said that. And we couldn't get to the point because someone else was jumping in talking about, you asked for an explanation, but want him to say, like, no. What, Zanuck, did you just claim that linear relationship doesn't work on a flat Earth?
I said that it does give you representation. You're using basically the logarithmic relationship is the error that you've discovered, and it's only happening near the equator for objects in the sky.
That's not
Any
true.
other spot, it is true.
No, it happens all the other places.
So if you do take what I just posted in your tag you two Witsit on it, and just do a simple observation of certain things in the sky with that 60 nautical mile for 1 degree relationship, without looking at things that are near the even if they're near the horizon, you can still use them, and you'll see that some of these values will be impossible. Not to mention, then you can then start also measuring the height of these objects, because it makes perfect sense. If it's flat and you have these angles, you'll know exactly how high that tree is by knowing the distance and the angle to the top of the tree, right? You know that. So we can actually fill in the blanks by saying, okay, that means Polaris is 3,900 miles up in the sky. Now that's easily to dispute as well.
So you're saying that's exactly a linear 69 miles per degree relationship when it's at 90, 89, and 88 degrees?
Yes.
Really?
Right.
So when it's right at the horizon, it immediately moves up 69 degrees, right?
Well, not right on the horizon, but after you get past.
Oh, hold on. Wait. What do you mean past that?
I'm sorry, I didn't understand your question. So.
Oh, like, so how long would it sit at the horizon without moving before it would move up on the horizon linearly?
I would say, if I was a guess, this is a guess, by the way.
About like 15 degrees. Let me go ahead and help you out. Oh, there we go. About 15 degrees, right? So right about when that linear relationship seems to be appropriate, that's when it responds linearly, is what you're saying.
Well, if you have errors that are near the horizon due to things that we all accept as truths and reality,
like,
and you don't use those.
wrestling.
If I'm doing any kind of experiment, I know there's errors in these certain regions of the test. I don't use those errors of region.
But ask him to follow up. Okay, then it should definitely work above 15 degrees, right?
Correct.
So it should work all the way up to zenith?
All up to zenith, correct.
Okay.
So from 70 to 100 would be no problem.
It would work perfectly with the linear relationship, right?
70 to 100?
I think, well, what Rakia
Go
said
up
about
and
that
right up.
gentleman, the gentleman that said that it's difficult to take a reading, at that
just
angle.
wondering, like, what
the
the
horizon.
90 is very
know about
accurate
it.
because we know how refraction works. So whoever says that, I think you might be misinterpreting what that they were speaking about. Because
All right, let's just
70
repeat the
to 90 is there's no angle of incidence, relatively speaking, no angle of incidence for your observation of an object in the sky through a differential medium, through a gradient medium.
Okay. So the Globers have claimed that there's a linear relationship with the Earth and the sky, and it's 60 nautical miles per degree. And that's because the Earth is a sphere. And since we have a celestial sphere around an actual sphere, we have a linear relationship. And the fact that we can use that linear relationship of 60 nautical miles per degree on the Earth to navigate proves that the Earth is a sphere and cannot be flat because it wouldn't be linear. Okay. Now, when we say, wait, okay, how come that you actually can't use that claim, linear relationship, below 15 degrees? You said refraction. Then we said, okay, so then everything above 15 degrees could be used, right? You said yes. I said all the way to zenith. You said yes. Well, the actual tables tell you that you can only use the measurements between 15 and 70 degrees. Why is that?
I don't know. You show me where that is said, because that doesn't make any sense to me.
It doesn't
Say
make
Shane
any
was
sense that you can't wait from 70
Shane,
to 90 you can't use it. That can't be right.
Well, Zanuck, it's the below 15 degrees. You've got refraction that's skewing your observation, and then everything above 70 degrees is a difficult observation to make in relation to the horizon because you've got your sextant stretched out to 70 degrees, right?
Oh yeah, that makes sense. So that doesn't.
Oh,
really,
can you cite where it says that?
that doesn't. Yeah, that's what it makes.
That's
what
what
I'm saying.
Rakia said a while ago.
Well, no, don't equate that to me. That's what someone was trying to tell me. Like the range, he didn't even mention refraction for the below 15 degrees. So I'm just telling you what he said. He said the common range is 20 to, he said 20 to 60, 20 to 68, or I'm sorry, 20 to 80. He said anywhere above 20 degrees and below 80 was comfortable. What he meant by that, I don't want to speculate, but I would try and find out who told y'all that. Like,
Yeah, Bacon said that to me,
That
right?
chart
I've
shows it
never
represents
seen that
20
before. Never heard
That's
of
what
that.
Bacon said. I mean, that corroborates.
I said that earlier. It's not true. Out of all the research, I've never seen a problem. In fact, what it says is that 90 to 70 is clearer and perfectly fine for measurements. So I've never seen it written like that in any celestial
But
stuff.
Data,
that I've
we
studied.
agree on one thing for sure.
Yeah, but it could also go inversely the other way anyway.
Well, I don't
So
know
I
that.
think
See,
Bacon's full of-
you're giving
No,
me.
Bacon
You
is
just got a
citing
graph.
the actual manual, though.
Well, you get a manual of a sextant, which uses the horizon and uses the dip angle as well as refraction to make that elevation angle. Then you can subtract it from 90 and then get a co-altitude angle. When in actuality, all we're looking for is a co-altitude angle, which is easily obtained without even looking at anything near the horizon, just a vertical. So this makes sense then. Now, see that, Shane, you put a blank chart up there. I don't know where it came from, what it's actually depicting. And now suddenly it's coming to my attention where this is actually, where this error comes from, where this non-linearity becomes apparent. And that happens because of the fact that you are referencing something that is apparent, and you need to adjust.
Okay, wait. So let's make sure everyone understands. Okay, so they claim that it doesn't work on a flat Earth because there's a linear relationship. But now what we find out is in reality, you can't use that assumption of a linear relationship everywhere. It doesn't work. It doesn't work. But now but I'm not done. But if we actually know that we have, say, curved visual space, we have like a personal dome, we have a limit to how far we can see, which the Globers somehow act like doesn't work. They act like that isn't possible or doesn't make sense. We have an equidistant limit to how far we can see in all directions.
That's not true.
And I'm just going to, okay, wait, why are you saying that doesn't make sense?
Doesn't make sense at all, because you can easily find some object that is your visual limit capacity, and then you can just zoom in with a telescope and see further. So that dome doesn't seem to make any sense.
Okay, wait. But does the concept of us seeing in an equidistant limit in all directions to give us a circle around us, does that make sense?
It can be mathematical sense, but it doesn't make sense and logically it doesn't make sense, because we know we don't have things that are equal distance from us surrounding us, because we can measure that they're not equal distance from us.
No, I asked you if having a limit to how far you can see, being equidistant, circle around us, does that concept make sense?
Yes, that makes sense.
There you go. Yeah. You have to say that because that's what your
No,
model says. Your model
no,
literally says that's what happens and that we have a visible universe, which is an equidistant limit to 46 billion light years in all directions that gives you a circle of how far you can see.
I don't know how that relates to the question we're talking about.
Well, you
No.
don't know how it relates. It's the same concept. So when I asked you, does the concept make sense? And you said no, but then I pointed out that your own model uses that very same concept. You
You're
don't know
twisting
how it
actually the
relates.
question you're twisting the question around several times there. Yes, we
You can't
see.
rebut what I'm saying.
If I see a given size object in the distance, and it is an angular size that I can just barely make out, so my diffractive limit, the angular resolution limit of my eyes, then yes, all objects of that same size would be the same distance away from me in a big dome around me. I would agree. You're what are you doing? You're hijacking that whole idea and saying because that is true, then everything is surrounding us in a dome.
No. What I'm stating is a fact that your own model claims that we can see equidistant in all directions. It's called the edge of the visible universe. Okay, so you guys can no longer claim that the concept makes no sense. Your own model invokes the very same concept with a different application. But it doesn't matter anyway because it's just common sense. If you have a limit to how far you can see, that limit is going to be equidistant in all directions. That's going to give you a circle on the horizon, and that's going to give you a dome over top of you. Okay. Now, if we're looking out on the Earth with this dome, then what we're going to see is this very curved relationship that you guys claimed is the sky, or you guys claimed is the Earth. Okay. So you can use a logarithmic function and absolutely explain why we have that relationship on the Earth with the stars. Objectively, the math is in the chat. It's not complicated. You're just inverting it. So of course you can do it.
Well, barring the errors, all you'd have to do is then call somebody a certain distance away, have them look at the same body, and find out what angle, a co-altitude angle they're observing that particular object or in the sky at, and you'll find that won't apply anymore. It won't make sense that they have a 60 nautical mile per degree relationship between you and that person that's also looking at the same position in the sky at whatever time it actually gets there.
Why would it not work, Xanax?
Because that would mean the surface has to be curved and the sky wouldn't be curved. Because you couldn't have someone at a different spot or even at the same spot. If you have someone that's looking at something, a star, let's say, right above your head, let's say we're looking at Pleiades or something, and say it's right directly above your head. And then you call somebody 1,000 miles away and say, where's Pleiades in the sky? And he'll say, it'll give you the number. And then that equates to the distance to him. The angle you obtain equates to the 60 nautical miles per degree relationship for the distance to him. Then you realize that surface has to be flat for that to happen because it does not follow trigonometric laws in any way, shape, or form. You can't run around it or repackage it by somehow equating the errors you see at the horizon due to refraction to a ubiquitous answer to all observations.
What if it was like backed up by studies and supporting things and other things that concluded the same geometric expression with the same, say, dynamic approach to distance scaling that would, mirror, say, like a bifocal with a near and a far field, dude? What do you think?
No, I say just.
I don't think so either. Sounds great.
I know, but just take something simple in that measurement, and then I want to see the graphs and the math behind how you can talk your way out of that one with some type of
no talk, just math, bro.
Visual space answer. I mean,
there's nothing needed to talk your way out of, Xanax. This is so very basic and simple. You should go talk to Bacon and Ruif about it and tell them why it doesn't make sense because it's just basic math. And both of them immediately knew that it makes sense and it works. Immediately knew that it works. So you should go talk to your fellow compatriots, I guess, about it. So it's very simple, actually, because you're just basically inverting it. Now, the part that's funny, though, is we have superior explanatory power, though, because we can explain without baselessly invoking the idea of refraction wherever you need it. We can explain that the reason that the rate changes, the relationship changes closer to the horizon is you're reaching the compression that starts to converge into your limits. So the rate would change because it isn't just linear. You guys cherry pick the linear portion that's relatively linear and act like that's the case everywhere and start making up excuses for why it can't be applied other places. We know that when you actually reach the extremities, that relationship changes. It isn't linear. So we have superior explanatory power. And of course, we also have a more logical position because we say, look, you see the plane flies over your head, looks like it's going up. Then it goes over your head. Now it looks like it's going down as it goes away from you. The street lights look like they're going down in the distance. The hallways look like they're converging because the ceiling's going down in the distance. Perspective makes things above you look like it's going down. You guys claim, sure, that is the case with everything else in existence, but it doesn't happen with the stars. And we say, no, it just happens with everything. So we have a superior position in many ways.
Explanatory, but not demonstrable, right?
It is demonstrable. How's it not demonstrable?
Dude, I'm gonna go walk the dog. I'll be back. You guys should go read all the stuff.
You haven't shown it to me.
There's
It's literally
database.
in the
Go
chat.
start there. Yeah.
Yeah. We haven't shown it to you, but it's been in the chat for an hour. So then I'm glad that we all agree that the Globers can no longer claim that using 60 nautical miles per degree to navigate proves the Earth isn't flat.
Why, Shane? Why in your graph do you have the exponential in the near field, and you have in parentheses
Because we're trying to figure out the actual relationship of how perspective changes based on distance, based on actual experiments that show that it changes. But
why do you say it's exponential?
That's a step. That's a step ahead. That's a step ahead of where we need you to first get, which is so you admit that you can no longer claim that 60 nautical miles per degree proves the Earth's not flat.
Yes, that does prove the Earth's not flat because you do in areas where there's not any errors, anomalous type of readings. The hyperbolic at extreme range, that tends to be an exponential function. You have logarithmic at the far range, looks more linear to me, and then your exponential / linear in the near field is linear. I don't know why you call that exponential. I'm still confused as Shane, can you tell me where you got this from? Because I bet I can dig into it and find out what they're actually trying to say in this particular, unless you did this yourself.
Just real quick to clarify, your position is that Bacon and Rueff are both wrong and don't understand the math.
They could be.
Okay. So Bacon, who's obsessed with celestial navigation and who has been claiming this very thing, which is that this can't work on a flat Earth because of the linear relationship for years. That's like his favorite argument. He makes it all the time. Has now immediately conceded, oh yeah, that would work. He's wrong about the math. He's wrong when he cites actual manuals that show the range that you can use. So can you specify and work it out and show where the math falls apart? And can you also cite where he's wrong?
I know where you're going with this. And I do know that in a lot of exponential functions will show linear relationships initially. And then that's why they call it exponential, because it's small changes initially and very large changes down the road. That's why you get these parabolic type of shapes and things for plots. So that's not, but I mean, you're kind of claiming because we see something linear in this one area that's part of the exponential function, because at the end we see it curving off. But the reason it's curving off is what I think Lefland had mentioned, is because it's curving off at the end because it's all based on the errors that are made at the horizon, and those are much more exemplified at the end at the longer distance, because it's has much more power to distort things at the end of this observation range than at the initial observation ranges.
So all you did was explain how you think that the globe can also explain why the linear function stops working at a certain point, and admitted that obviously the flat Earth with a visual dome can also explain that. In fact, that's the specific prediction of it. But and you did address the actual point, which is that the math works on a flat Earth to have that same relationship.
But it doesn't work in the initial areas. So even though there's a close relationship, it's not as dramatic. If you have accurate measurements for things that are above your head that are not being distorted by refraction, that linear relationship of 60 nautical miles per degree cannot work on a round surface, no matter how you position it. It doesn't work. I've already shown you the examples you can show, and you can actually validate yourself. Go make a measurement, wait some time, or call your buddy some distance away, see what his angle is, and see if the distance corroborates with the shape of the surface, and you'll find that it won't.
It absolutely will. You have the same relationship if the flat Earth has a visual dome with a radius of 3959. It's basic math.
But you can validate that by measuring where that object is in your field of view at other points. Once you get 3 or 4 different measurements, that will dispel whether it could be a dome and a 3959 radius to every object above you, and how is it going to be a 3959 distance above him as well.
No, it won't, because it's exactly the same. It's a personal visual dome for each observer.
And we all have our own personal visual domes, right?
We've been saying that the whole time.
I know.
So basically,
I'm
so
just
basically, at the
formatting
conclusion of
just
30 minutes, you just admitted you don't even know what the argument is, but you know it's wrong still. And what you're going to do now is skate right past it and claim you still know it's wrong, even though you didn't even know what it was this whole time. And let's just skip to the end.
They would also overlap depending on if the two viewers were the same distance from the point that you're looking at. Like the domes would overlap.
And again, I just point out, the reason I pointed out was like, you're it's so funny. You're like, oh man, yeah, we each have little domes that follow us around, trying to make it sound stupid. And your own model invokes the very same concept, saying that there's an edge of the visible universe that's equidistant from the observer.
Correct. Let me ask you a question.
Each
Danny.
observer.
Is perspective observer dependent?
Yes, perspective is observer dependent.
So no two observers would share the same
Yeah, I have a question.
perspective, right? So perspective geometry would be specific to each individual observer. Would you agree?
Only on certain axes. Because if two observers looking at an object same distance apart would see the same reduction in angular size. Any two observers that are
I didn't ask about angular size.
What?
This wasn't about angular size.
Well, that's what perspective is made up of two things, right? Where things fall in your field of view based on distance, and also the angular size of objects getting smaller.
What about with respect? What about with respect to where the item is you're looking at?
What about two observers? What about two observers looking towards each other 3 miles apart? Are they seeing a convergence that's both optical between those two distances, or is it physical shape they're witnessing?
Both.
So physical is causing a convergence between the 2 points, or is it an optical illusion causing the convergence?
It's not optical illusion, just like there's no optical illusion with something in my
so
field of view.
for both observers,
Data. Let me finish my thought real quick. There's no difference between that and something in my room, like a guitar in the guitar in the corner is higher in my field of view. It doesn't mean it's actually physically higher. It just means the perspective puts it higher in my field of view angularly based on trigonometric laws.
Well, maybe define optical illusion, because when I look it up, that's exactly what you're describing.
Yeah, we've had this conversation 100 times, and he's just objectively wrong about it.
Yeah, he's just trying to say that it's Euclidean when we already went over earlier, I guess, when Zanuck wasn't here, when Jesse tried to do kind of the same thing, where we went over that perspective geometry is non-Euclidean, but he's trying to say that it's just simple geometry. Maybe at a very small scale, but perspective is not just at a very small scale. It's not just your room.
I'm using Euclidean geometry to determine the height of this tree across my street.
We're not determining the height of anything. We're talking about how visual space is represented, meaning it's non-Euclidean, because in reality,
I get that.
parallel lines do not in reality, parallel lines do not intersect, right? So you can't just use straight Euclidean geometry in order to articulate or illustrate a perspective geometry. Perspective geometry has axioms that are incongruent with Euclidean geometry.
No, they're not.
Yes, 100%.
No,
they
I can say parallel.
Exactly
hold on, let me
what
respond.
they are.
You've said a lot there. Let me respond to it. So parallel lines, like railroad tracks, they are parallel. They go off in the distance. Euclidean geometry dictates exactly how they will converge to one another from the point of the observer. That is not.
No, it doesn't.
No, it doesn't.
One of the
Zanuck,
main
you're-
one of the main postulates of Euclidean geometry is that parallel lines do not converge.
Exactly,
They
Zanuck.
do no from a certain you use those calculations of trigonometry, which are Euclidean based equations, to determine how they will convert. For example, if I have railroad tracks and they are 5 feet apart, and I look off in the distance, any distance, 100 feet, 100 miles,
We
I
know
will
what happens
see
in
a
reality, Zanuck.
convergence,
We
and
don't
there's
need
a
you to
convergence
articulate.
angle of where they will be from my point of view to that railroad track at 100 miles, and it'll be
Answer
a
the
different
question.
angle at 100 feet.
Answer my question, please. Is it a primary postulate of Euclidean geometry that parallel lines do not converge? Yes or
Yes.
no?
Correct.
Okay. So if perspective is strictly Euclidean geometry, that would mean that parallel lines wouldn't converge.
From the observer, they do
Dun,
converge.
dun, dun. Yeah, from the observer.
Thank you.
Hold on. Let me read this for Zanuck because I don't think he was in the room when I read out the axioms of projective geometry, or what we would call perspective geometry. Any given geometry can be deduced by an appropriate set of axioms. Projective geometries are characterized by. Wait, hold on. Let me read it.
Yeah, you better read
Yeah.
that because it's going to talk about projective geometries still being Euclidean. Non-Euclidean is more like spherical geometry. It's not Euclidean.
No, it's not more like anything. There's different versions of non-Euclidean. You have hyperbolic, parabolic, elliptic. That's not what we're talking about.
I'm not
We're
talking about that at
talking
all.
about how it's non-Euclidean, period.
Yeah, so perspective or projective geometries are characterized by the elliptic parallel axiom, which is that any two planes always meet at just one line, or in a plane, any two lines always meet at just one point. In other words, there are no such thing as parallel lines or planes in projective geometry, right? So there is no such thing as parallel lines in perspective geometry because perspective geometry has more points than Euclidean geometry.
And if there's no such thing as parallel lines in projective or perspective geometry, then perspective cannot be Euclidean geometry, as it specifically has a primary postulate about parallel lines and how they don't converge.
Yep, not without a transformation, right? That's why in mathematics, projective geometry is the study of geometric properties that are invariant with respect to projective transformations. This means that compared to elementary Euclidean geometry, projective geometry has a different setting. Projective space has a selective set of basic geometric concepts. The basic intuitions are that projective space has more points than Euclidean space for a given dimension, and that geometric transformations are permitted that transform the extra points, called points at affinity, to Euclidean points and vice versa.
That's
So you have to have a
straightforward point
transformation
blank.
because what we see visually, right, is non-Euclidean. So you can transform it and you can claim that this how you visually see is technically, the Earth curving or the Earth being convex or concave at any point in time based on your what you're seeing.
Well, that's
But
not
that's
exactly what he's saying.
And like, well, let me say one more thing, Zanuck. Think about what you said. You said so. You just point blank read it. It's different. You have to transform it. You actually invoked it and said you have to use that perspective as Euclidean to even figure the stuff out, to work it out. And the actual truth is, no, you have to transform it to try to match what we see. This is what the Globers always do. They take the discrepancy and they turn around and invoke the discrepancy as if it's positive evidence for their claim.
It's funny how people that know math, understand math, trying to explain things to you correctly, that you suddenly compare it to your misunderstandings of the math. Are you saying that 3D? So math in 3D does not use Euclidean geometry. 3D math.
I think I made my claim pretty clear. I think that you're
just answer
avoiding
that question, because that would give you all the answers I need. Are you telling me that when I do math in 3D, that is not using Euclidean geometry?
What I'm saying is that if we actually use
can't answer,
Euclidean
can you?
geometry, because it's not a sufficiently specific
It's
enough
a
question.
very
Like in
succinct,
3D,
accurate.
No. If we're using perspective, we cannot strictly use Euclidean geometry to accurately describe perspective. It requires a transform. So this proves unequivocally, and I've said it 5 different ways, 5 different times. I'm going to say it one more time. I'm not going to keep repeating it. You just keep avoiding it. The primary postulate of Euclidean geometry is that parallel lines do not converge. Okay? But we see that in reality, when we are looking at something, perspective causes parallel lines to converge. And in fact, there are no parallel lines in perspective. Therefore, perspective can objectively not be Euclidean.
Okay, I'll ask it. I heard everything you said. And I understand what you're saying. I'm going to ask you one last time and just answer yes or no. Can you use Euclidean geometry for 3D math?
If you transform it.
No, without transforms. So
Can
3D
you?
math.
Yeah, sure.
I have a graph X, Y, Z, and I have a piece of paper, and I'm going to do
Sure.
some calculations. Do I need
Sure.
anything other than Euclidean geometry and trigonometry to plot out things on a piece of paper for 3D math?
No.
Thank you.
Okay,
Rest my
non
case.
sequitur. So when it comes to
It's
perspective,
not a non sequitur.
When you're
it
mapping
literally is.
something out on a piece of paper, you know the length of the line. You know what I mean. You can measure the interior angles, etc. That's not what's happening when you're making an observation.
Sure, it is.
Oh, it's just
Exactly
literally
the same.
non-sequential to the point. The point is that when we there are no parallel lines in perspective, and that we see that parallel lines appear to converge due to perspective, and that Euclidean geometry says that parallel lines do not converge. Therefore, objectively, perspective cannot be Euclidean.
Well, I think you have a misinterpretation of parallel lines in Euclidean geometry and 3D modeling, which is non-Euclidean geometry is something entirely different. Non-Euclidean geometry is used for something on a sphere, for example.
What? Okay, it doesn't just have to
Non-Euclidean is
be a
used on a
sphere.
sphere.
It doesn't just have to be a sphere. We've already addressed that red herring, and it could be parabolic, hyperbolic, elliptic. It can be many different versions in between.
Sure.
But that isn't actually even relevant to the point, which is that the way that we see is not just in Euclidean geometry. If we saw in Euclidean geometry, then when we saw the parallel railroad tracks, they would just remain parallel. They wouldn't appear to converge because
Okay,
the primary postulate, the primary postulate of Euclidean geometry is that parallel lines don't converge. So that means perspective is causing a change from the Euclidean physical reality to our perspective, to what we see. There is a change. Hence you having to use a transform, which means change. All right,
Well,
glad that we got that
you're
covered.
just wrong about that. It's okay. I think we've had to come to a point where we just had to agree to disagree.
What?
Because just like I can get a distance to the top of a tree, which changes with distance away from it. I can get I can put something on a piece of paper, X, Y, Z, and use Euclidean geometry all day long till the cows come home for railroad tracks or trees or buildings or angles, anything in the distance. And where it is in the field of view, all is Euclidean. That's dictated specifically by Euclidean geometry. It's the reason you can find the top of a tree's height only by knowing the distance to it and the angle to the top.
Yeah, but we can also use non-Euclidean geometry because it actually changed at the extremities. We have all the papers showing exactly how it works, determine the height of an object and the distance using non-Euclidean perspective, because it actually changes based on the near field, the middle, the medium range, and the far field. This has all been mapped out extensively. It's even been backed up with tests. And you can actually use your Euclidean geometry at great distances to determine the height of an object. It doesn't work. I wonder why. It doesn't work. Because perspective is non-Euclidean. That's why it doesn't work. It's been extensively written about and shown that your claim is wrong. We just now broke it down with simple logic that your claim is wrong. Someone can go out and look at railroad tracks and prove your claim is wrong. We just now showed you're violating the law of non-contradiction and double speaking, and then you just keep on baselessly claiming I'm wrong anyway. So it's whatever. We conversation over.
No big deal. Listen, like everybody gets a prize, Anik. Yeah, you get to measure like trees that are like 50 feet away, and everybody else gets to measure, much larger. But you got your trees, so
Well, he's
You good?
right. There is a distance limit to Euclidean. You can accurately measure the height of a water tower or a tree or whatever at close distances. But that's what I've been telling you for years, Zanuck, is that it has a limit distance or distance to the. I'm getting tongue tied here, but there's a limit to it. You can't do it at far distances. I don't know why
Correct.
it's so hard.
Sure you can.
Yeah, no, you can. You can, but you're going to be inaccurate.
Correct. And that's a fact. It's
So
just a fact.
if I'm on a flat surface, I assume it's flat, and I just look at the tops, you'd be correct. But I can look at the bottom too, and that straight line to the bottom, a straight line to the top will give me an accurate height of that tree.
At what?
Oh,
at
a
what-
straight
at what
line?
distance? Yeah.
Straight line.
Wow,
We're
a
not
straight line to
talking
things far in the distance. That's crazy. How's that work?
And also seeing the top and the bottom at far distances. Where do you see that at?
What's that?
Where do you see the top and the bottom of an object like a tree or a mountain, for that instance, from
At
far
great
distances?
distances.
You can
Elevation.
go look at you can go look at your Kanagawa. You look at your
The
Kanagawa.
earth is
look at
flat now. The
whatever
earth is flat now.
whatever that bottom of the mountain you can see, might not be the actual very bottom, but some point below the top, you can actually approximate what the elevation or the height up from the top to that bottom part is actually valued at by just
Yeah,
how
just
far
turn
it is
the
away
map,
and the angle
right?
change and the angle size of it.
Yeah,
No,
just
now you
turn
can
the
just
map.
estimate. Now you can just
It's a
estimate.
measurement. It's a measurement.
Yeah, you can. Listen, now you can just estimate, not even knowing exactly where you are in the elevation of that mountain, because you can't determine exactly how much of it that you're seeing, and then you can just
No,
estimate. And,
you
and,
can
and
you can
Zanuck
have
says
a
it works. The
you can have
actual
like
paper, the academic
you can have a
papers on this say that it doesn't work, but Zanuck said it does.
you can have a cutout or some plateau. You actually can visually see a slash in the mountain. You know where that is. That's probably it's got a name. You can see that compared with the top of the mountain. Get the angle, know the distance to it, and then figure out how much that and validate what the distance is to that top of the
Well,
mountain.
after you figure out how much it's compressed.
No matter what.
Yo, and check this out. Check this out. So there's a test that they did, and when they actually assumed Euclidean geometry, to actually map out like the relative relationships of what people were observing, it was off by up to 30 degrees.
For what? What's off 30 degrees?
For an equilateral triangle, using perspective to map it out, was off by up to 30 degrees. It showed the illusion of spherical excess.
Spherical excess, baby.
Oh,
There's your spherical
Yeah,
excess.
dude. Exactly,
how
dude.
you
There's
measure
literally a
spherical
test.
excess.
There's literally a test where they had an equilateral triangle, so 180 degrees, where they were using perspective to map it out, and it actually gave the illusion of spherical excess, and it was off by up to 30 degrees.
Wow.
This
Wow,
is
what?
why
This is a literal test that you can do.
Yeah, this is why your measurements of the globe Earth seem to get more accurate when you're measuring over longer distances, because you're just bringing into account the more extremes of the spherical nature of your vision.
Those aren't actual measurements like via lasers or something or sight. These are measures along the ground with distances, which is a big difference. When we measure
what?
spherical axis,
What?
Like the
you
arc of
have
the
to measure
parallel?
the triangles angles, 3 of them, and take random or alternating angles from all 3 of them, add them together to your spherical axis. You're not going to ever get
That's what they
spherical axis
did in
by
the
just
test.
measuring. Okay, so I can't respond.
That's what they did in the test. You haven't read the paper. You're telling us you know it's not the same. You don't even know what it is.
Where does it say they were off by 30 degrees? Do you know what 30 degrees would represent at 100 miles?
Dude, it's a small triangle showing that visual space is curved, and it was off by up to 30 degrees, and it's in the actual abstract of the paper, Left Lane.
You realize 30 degrees over 100 miles is a lot more distance in that line than 30 degrees of 10 miles, right, Left Lane?
That's what I'm saying. I don't see that there's any way possible they could be off by 30 degrees in an observation.
Well, no, what happened was they showed that perspective is not this like super simplified, like consistent ratio, that it changes, that the actual curvature of visual space changes in the near field and the medium range and in the far field, and it's dependent upon angle of view, it's dependent upon aperture. You mean like they were actually accounting for all the variables? instead of coming around with caveman math, denying all the variables and saying, well, we can just use Euclidean geometry for perspective, even though it's wrong. We can assume that it's the same from here all the way to wherever we're observing. We can then use instruments that are far beyond their accuracy range. And then we can say that everything that we see displaced from what should be Euclidean is actually the Earth curving. So this is an actual precise test accounting for all the variables, done many times, dozens of times with many different people. And this is where the Glober hasn't read the paper. They don't know what the paper is, but they know that I'm wrong about the paper. They know that the paper is wrong.
Well, yeah, of course. I mean, well, most of these people are still operating as if NASA is, a fair and truthful and honest organization. So they probably don't even care to look at what you're bringing, because they still look at the NASA pictures and go, ooh, because I know I remember Doofus the other night when you were talking to him, talking about you're picking it apart, and I'm imagining being up there. Like, that came out of his mouth, and I was like, that tells the whole story right there, because that's the truth. It's
That
their
was me.
imagination. Yeah, that's you. Okay, you're not Doofus. You're omnivore. You're omnivore, right?
That's
I'm not at
No,
my.
left lane.
Oh, okay. I'm sorry.
I am
There's voices.
omnivore.
I'm not looking at the screen, right? I'm trying to guess the voices. Y'all all sound the same.
Well, not really. But like, this is what I'm saying, bro. Like, oh wait, on that note real quick. Hey Zanik, do you still agree that there is some evidence that looks like they may have occasionally been like faking some of the imagery from space, and while they claim to be in space, but your position is even if they do occasionally do some type of production, that doesn't mean that they're not actually up there?
I don't think Xanix's a big outer space believer. Dude, he's a
Zanik
math lover.
said that to me like 3 times. He's like, whenever some of these things are super damning, he's like, yeah, that does look kind of sketchy. They may be faking some of this, but like, even if they're faking it, doesn't mean that space isn't real or that they're not really up there. So I gotta tip my hat. At least he took this step in the direction of acknowledging that it clearly he's not just gonna make anything up at any time. Yeah. I was
Like,
wondering
with
if you
respect
found
to
back on
Zanik,
that.
he does like things that he can tangibly work with. He doesn't bring up a lot of things that he couldn't at least attempt to validate.
I mean, that to be fair to Zanik, that's like a home run argument for them, because there's no going beyond that. If we're like, look, we're showing them faking space, and he's like, yeah, but I mean, like, even if they're faking some of it, that doesn't mean they're not really there. They may just be reasons like, oh, it's too difficult to actually broadcast it, or maybe it's too difficult to get the film for that specific thing. So they're just going to show us what it does look like or what it should look like, but that doesn't mean that they're not actually out there. Yeah. It's like, damn, bro. There's no way to falsify it to you. Like, there's nothing that could happen. Like, you could show them get caught faking it 100 times, and then it still wouldn't mean anything.
Hey, I want to tie something back to what happened earlier. There was a laugh, like a chuckle, at the idea that we all have a personal azimuthal grid of vision, or a personal dome of perspective that we carry around with us. But it's not like there's a bowl or something silly that follows us around. All it is we're human beings with eyes. Anybody with, 2 working eyes that can see far, that's, has good vision, they're going to have a particular grid of vision. And then if you go up in altitude, or you climb to the top of a 14er, or you're up in a plane, that gives you a much bigger perspective dome of vision. It's not some silly little toy. It's how humans see. And then once you start breaking down, okay, well, what are the luminaries? What's the sun? What's the moon? Where are they? So the Globers have the story of how far they are and how they got to that point. But if they are closer, and if they're presenting to us on our perspective dome, then you really have to know how far apart are the people, at what latitude, at what longitude are the people trying to look at the moon? Because isn't it true, and this is my question, isn't it true that that's important to know the angle at which 2 different observers from 500 or 1,000 miles apart are going to see a closer apparent object in the sky? Because it gets confusing whenever you're like, no, that's 239,000 miles away, and we just both look at it, anywhere on the side of the Earth that's basically can see it. See, that's conflating the heliocentric story / narrative to what the flat earthers are saying isn't true. Reality is that these items are apparent and they're closer. So can you give me feedback on that, anybody?
All the stars are closer.
Yeah, but I
All the
mean,
stars are blue.
if you got somebody on the equator or somebody in the northern hemisphere a little bit and a little bit below the equator trying to look at the moon and take angles to it, aren't they going to have a little bit of a different view of it because it's specific to them as well, right? And I guess my last thought, then I'll pass the mic because, I'm just trying to learn all this stuff. Navigating by the stars, like it only mattered to the person on the boat that was trying to go somewhere. Everybody on the boat is looking at the stars and they can navigate no problem with this azimuthal grid of vision and the stars being presented to them. But I think it has to be a plane surface to get that flat baseline. And I don't know, the world's flat, man. The water shows it and figuring it out. And now the math is lining up. It shouldn't be weird.
Don't make it weird,
Yeah.
bro.
Yeah, I'm not sure if it matters how far away like the luminaries are. We see them like in in 2 dimensions, and then process it in 3 dimensions. And then yeah, I would imagine, like you had said, with 2 eyeballs, it's probably worse. 1 eyeball, you're probably better off. I mean, we all know you point at a spot on the wall with 2 eyes, close the other eye. It's hard to work it out.
Right. And then the thing with like the guitar in the room, that's linear. That's like across the room and it's in a straight line. But as you get to this limit or edge of your vision of how far you can see before this, apparent sphere kind of domes over you, I think that the sun, the moon, and the stars present to us from outside of our dome, almost like they're being projected onto our limit of vision. So it gets pretty tricky and wild. And I mean, a lot of people might say, dude, you sound like you're smoking crack and talking something silly. But if it's reality, that's awesome, and I want to know what it is. You know what I mean?
Yeah.
Well,
I had a question.
that's the whole spell, because the trick is that what's crazy is to claim that we see infinitely far away, we see in perfectly straight lines, even though we objectively and provably don't, and that the stars are all the same distance away, even though they're actually not. And that perspective causes everything to move down towards the horizon, except for the stars. They're the
Well,
exception. But that's
how do
the
you
actual
feel?
crazy part.
How do you feel about you look up at the night sky with a certain, I don't know, magnification? You zoom in a little more, you see a lot more. You start seeing more and more stars. Like, I mean, how does that go with the infinite? Seeing infinitely. Obviously, we don't, because we have to zoom in to see, and then more stars appear.
It happens with everything.
That would just be
Right.
resolution based on aperture. Right.
Right.
Wait, I have a question. So like I get that, like it looks like we got a personal dome, basically, which make the stars look like they're going around, but like on a larger scale, like we're in like a toroidal, like I imagine I mean I'm pretty sure we're in a toroidal field. So at a certain point, are they like kind of dipping down around us, like the toroidal field coming up around us? Like, aren't there stars in that part too?
I mean, good question, because there could be just a plane of stars above us inside of the overall torus field. Like
So
the stars don't have to curve down with it. Like it could just be a plane of stars above us, right? Because if you have say you have a dome, which is like a torus field, is basically like a dome, then you could just have like parallel planes of circles within that.
Yeah. So you don't. Oh yeah, because I imagine that eventually, like past Antarctica, past whatever lands are there, there is like a Truman Show like magnetic field dome with like maybe like stars that you can see literally horizontal in the distance. Like that we never see from our perspective. I don't know.
I don't know.
Yeah. Okay. But for the most part, it's like what all the stars we're seeing, they're not curving at all. They're just straight above us. Like they're parallel basically for the most part.
That's what I think. Yeah, I think there's like just a plane of stars above us. And then we have
To
curved
me,
vision.
that kind of makes. Oh, sorry.
Go ahead.
I was saying that kind of makes sense with the plane of stars, because I've heard you talk before about having to have Gaussian surfaces for the electric field. So if it's a plane above and a plane below, that kind of makes sense to me.
Exactly. Yep. And like what's serving as the plane above, who knows, right? Like there's a few different ways that could happen. There could be like something serving as the solid plate above that's within these parallel planes, right? And there's an overall dome even outside of that. The way that you would really start to measure this out is you go to the theoretical edge. You get closer to the edge and you'd see that the the uniformity of the electric field drops off, like the actual field itself changes. Which obviously, I've never been there.
Well, why don't we just go to Antarctica? It's so easy, the Globers say.
Yeah.
Because apparently you can find out everything at the coast of Antarctica, that base they got there. It's all there.
Yeah, you can study deep down in holes from just that one spot, no matter where. Like you can go like 8 million miles away from that area, but just study right there and don't leave
Perfect
it.
timing.
Yeah.
Yeah. Why don't you go? I mean, since you already beat up Jeremy, why don't you go over with what's it there about this electrical vacuum? You guys might have some insightful info. You don't have to at all, but
About an electrical vacuum?
yeah.
I've never seen one of those.
Well, what vacuum doesn't have electrical gradient inside?
No, they were having Jeremy and him were having some kind of conversation about when you in a lab when you pull from a vacuum chamber, right? Like what are you pulling from that chamber? And I think it might have been said that it was like electrical potential or something being pulled from the vacuum instead of molecules of air or water.
I've never heard of that. I think it's just air.
Yeah.
Yeah, but you can't pull the air out. That's what creates the idea of what's called the vacuum, because you're not really pulling that out. It's staying
So
there.
you guys are saying the ether doesn't exist, but you know how to pull it from vacuums. Got it.
I don't know what the hell sense that just made. I don't know what ether is. I'm saying when you put two things together, you're not going to pull whatever's in between that gap right there. You're not pulling nothing out of there. It's still in there, brother. So however that helps you. You take two things together and you try to pull them apart. All you're doing is making it's a converter. You're doing a process. You're doing an action or a reaction, and from that you're going to see another action or reaction happen inside.
Okay. All right. So before we move on, there was a lot of stuff that was said the last few hours. I might even go back and listen to this because there's a lot of information. Could we? Is that conversation concluded or not? Like in terms of the visual space, the stars, celestial navigation. There was a lot of like cutting edge new information as well. So just wanted to see where we're at with that before we just go on to some other topic.
I think we did cover pretty extensively. I mean, basically Shane did the math and showed that you can explain the 60 nautical miles per degree or the 69 statute miles per degree relationship with the Earth and the sky on a flat Earth, and that it actually works better at the extremities because we would expect it to change because it's logarithmic instead of linear. And basically, it's just that if you have a personal dome with around 3,959 mile radius, then you would have the exact same relationship in reverse, only it's actually that visual limit, that curved, like equidistant dome, that that causes the way that the sky appears to drop. Basically, what they did was they looked at the sky, they made the measurements, and they claimed that we could see forever. They took that curvature and put it on the ground, right? Which we've kind of been saying for a while. But basically, Shane just worked out all the math. And then when you start to think about it logically, like perspective is provably not Euclidean, right? Like even with railroad tracks. So that's basically like a quick summary of the situation is we've taken back the celestial navigation argument, the claim that the 60 nautical miles per degree disproves flat Earth, and proven that that is not the case. The math works perfectly fine. We've gone to like the top guys on the globe, given them the math, and they've all confirmed that it does in fact work, although reluctantly.
Well, Ruhiv said make a prediction, and Bacon said, perspective can't possibly work that way. But yeah, absolutely.
Yeah, well, of course they don't agree with the conclusion, but it's that the math works. It's that you could go out on the Earth and the math would work perfectly fine, right?
Yeah, they definitely agree with that, but then disagreed on principle because if they conceded, the whole argument would be over, right? Like, I understand.
But isn't this like globe dead, right? So if it works, the math works and it has predictive capabilities, isn't that their like gold standard for everything that they claim proves the globe?
Yeah, that's why I immediately wanted to test it at the equator with Zanuck, who immediately said, yeah, that no, it goes negative and would be, useless, break apart, non-predictive, fail, and then like, oh, but logarithmic would do what? Yes, correct. Right, so that was it. That was the whole predictive power thing being over immediately.
They knew about curved visual space from the 1850s, and your boy Carl Friedrich Gauss pretty much pioneered the whole thing and the theorem for how they could turn a rate or angular excess or spherical excess into a radius, and then how they could get back to that radius. Like it's like he invented all that. So like yeah, they knew about all this.
Oh my God, deception, conspiracy. Who would have
Curved hyperbolic space.
Well, they were like, the trick is, right, we're going to tell you, even though we derive this optically from the bottom of our eye, like Samuel Robotham knew so many hundreds, like 100 years ago. I keep saying that because it's like the only part that I read. You definitely figured this out. But like, so we just derived that instead of the physical curvature, we're just deriving it optically, both for spherical excess, when we can backwards compatible pull the spherical excess and the radius of the curved visual space out of the angular excess of the triangle. If I remember off the top of my head from that paper, Alan, I think something exactly like.
Yeah, 1-to-1. So they took the angular excess measured from the experiment and used Gauss's theorem for how you can turn the angular excess into a distance, which is the radius. And they applied that, and they were like, "Oh, look, there's a 1-to-1 relationship with that. Who would have thunk it?"
Right. So they just derived it optically, and then thus we could say like, hey, when we take the angular resolution limit and we apply it like spherically, right? And we say, hey, the end of our vision would extend like an arc, and we treat it like an arc, and we get the segment, and we do this compression limit because the whole game here is to try and quantify angular resolution, right? Because we've always said that would be the compression limit, but we have no math for it. Except if we start with the Rayleigh criterion, we can go backwards to get this like angular resolution, right? 0.0216 with a 6 foot, right? Lost at 3 miles, you get something like angular resolution limit over, like, if you say that's a line, take that arc, and then you can do some other math to solve and get the backwards, I think, radius 3969, which could just be the radius of your optical horizon, right? So if that would apply, then that would also mean that the 8 inches per mile squared parabolic expression, right, would just be like, it's like exponential. We would just say, hey, that would also exponentially apply to the optic scaling instead of the physical scaling, because that also works, right?
So is it no longer like the personal atmospheric dome? Is the atmosphere not playing into this? I mean, it has to. Obviously, one step at a time. You're not here to answer everything at once.
No. I got you, bro. I got you. Ready? Personal celestial sphere from henceforth. What do you?
Right, but then the atmosphere is obviously going to be, playing effects, playing a part in the different effects at different times and different.
Yeah, of course. It like exaggerates the effect. That's why sometimes things look higher or lower. Sometimes we see further, sometimes we don't, because it's basically like a giant lens because the Atmos is a medium. So it's like it's literally like wearing glasses, and it exaggerates the effect of the curved visual space. Right. And then on top of that, you have how much of that information that is light can actually get to me so that I can actually perceive it. And actually, light doesn't travel and get to you at all, but it doesn't matter. And intents and purposes, like from how far away can I see that light? Well, there's an attenuation. If there's too much atmos and too much
Right.
turbulence and too much
But there,
humidity and
but there
too
will be
much density.
attenuation at different levels, at different heights. It's just going to be. I'm not trying to put anything down. This is great. To put some numbers behind it. 'Cause this is what these assholes are always asking for. It would be, step one. I don't want to like go into step 2 or 3. Yeah, it's great, man. But yeah, it'd be different levels, different heights. It'd be a lot of stuff to have to quantify. Different absorption, at different levels, etc.
Well, yeah, to actually account for like what they call refraction and what the atmos does to observations is very complex. They come around with like their caveman math where they don't account for almost any of it and then act like they know. But like that doesn't mean that we have to like we don't have to like replace it because they don't adequately describe it. You see what I'm saying? Like it's so much more complex than that. Like their refraction claim is invoked to explain why we see further away. But we know one of the primary factors in why we can see either further away or not as far is attenuation. So they're invoking a claim based on the Atmos to tell us why we see further away, but they don't account for the primary variable that determines how far away you can see, which is attenuation of light. So, and then of course, resolvability. And so those two are joined at the hip as well. So that means you have to account for the turbulence of the atmos. You have to account for the density of the atmos. You have to account for the humidity, right? And then, of course, temperature fluctuations are going to be directly tied to the turbulence. And you're going to have to account for all of that to understand what the rate of attenuation is, the absorption rate of the light in that medium, to determine how much you're going to get. That's going to be joined at the hip with resolvability, because as things get closer and closer to falling below your resolvable angle, there's less and less resolvable information. And then that, whatever that amount is, now has to go through the attenuation equation, right? And then you can determine how far you would see it. You would have to account for all of that on top of the fact that perspective is non-Euclidean. In reality, the very specifics of making like precise predictions of how far you see based on perspective, visual space, and atmospheric conditions is extremely complex. But they want to come and tell you that it's super simple. We see perfectly in straight lines forever, and that more dense medium light bends down, and it's nowhere close to that simple.
We can't just add a radius value to every planar observation and call it a globe.
Yeah, and then Ruev keeps coming at me like, "What's it scary? He's running away because he can't do a prediction. He can't make a prediction." I'm like, dude, you didn't make a prediction. Like you took someone else's quote unquote prediction, and it's doesn't even account for like everything. Like it doesn't account for 90% of the stuff. So like that's not a flex. It's like I can make a really bad prediction. So until you can make one, like there's this phenomena that's super hard to account for all the variables. I'm going to avoid most of the variables and claim that I can predict it. Where's yours? Ha ha ha. It's like, well, I'm not going to ignore a bunch of the variables and then reify my model and then just come up with something I can move around so that I can claim that the earth is flat. I would want to actually know what's going on and then properly account for all the variables. It's, you know what I'm saying? So like we have all the universities and hundreds of years that created this and could only account for like a couple of the variables, but you are just a group of people that are heavily censored and have no funding in a few years, and you need to figure it out with all the variables. It's like, all right, bro. You got that. I am interested in it, but it's like
Yeah, but we do got
only
it.
so much we can
We
do.
do got it, dude. We do got this.
Yeah, but
I'm
it's
saying,
just so
I'm
much
saying,
so much
I'm,
we can do.
I'm saying we do, like, because it's all coming. All the resources we need are coming to do everything we want to do.
Yeah, I like the energy, brother.
Yeah, that was kind of inspiring.
That's my prediction. That's my prediction for sure.
I like it, Gio. I came into the scene 2 years ago and have seen such a progression and so many people coming up, rising to the top. I made the mistake of trying to defend myself in just the chat, and I realized 3 out of 4 people I was battling weren't even in VC this whole time. And I was like, you're not hearing any of this? So I don't need to go into the like text chat.
Oh,
No,
dude,
no.
it's crazy, JT dog. They're spiraling. Like they don't
I
even
know.
know the globe's already dead.
The
Oh,
text
anyway.
chat is a swamp.
Well, I mean, we could separate it to where only people in the VC can type in it, and then we could create a second one, or rechannel a lot of that traffic of people that are typing other stuff. We've talked about that. It will kind of change things in a way, like it'll separate it a little bit, but we could do that if it gets like too because I know there's often like multiple like different side conversations. I mean, I'm open to ideas too. We've talked about it, changing it up in some ways. Just
If
because
you look at the chat, so hey, dude, JT, if you look at the chat, that's what I see when I look at the chat. So there is a pretty simple solution. Like you see how I see 4 blocked messages, 6 blocked messages, 2 blocked messages. So my chat's like all positive vibes, bro. You know, I'm
so
saying.
just start blocking people.
Yeah, you're just hiding them from the chat, basically.
Yeah, you
I
got to
mean,
make
that is
you got to make
way.
a decision
That's
and know
like
that it's
moderate.
on you. Yeah,
Yeah, that's
it's on
like
you to make that
moderating.
choice.
That is a pretty clever idea because it's kind of like you just moderate it yourself, basically. Like no one mods it for you. Like we don't have to split anything up. It's just like that's an interesting way to do it. It's like you're able to control it yourself. Yeah.
Yeah,
Thanks for
man.
that
So
tip.
yeah, so you can go
Yeah.
in there and have like a positive vibes, and there could be
There it
someone
is.
just
Incarnation
absolutely,
talking shit about Witsit again.
but I
Right
can't
on
see it.
cue.
You feels what I'm saying? Like it's awesome. Like there's no telling what all they say. Every once in a while, like I'll just out of habit, like show a blocked message, and then I'm like, oh man, why am I doing this? You know?
Oh,
Like
that's
an
He
immediate
says that
regret.
he says you block
Wow.
people that are smarter than you, but I've never heard you talk to anyone that's smarter than you.
Well, I just like if they want to talk to me, man, they can come in here and talk because what I found is way more productive conversation takes place in voice anyway, as opposed to talking past each other and like, you know. So I mean, it's not like I block them or deafen them on VC or anything.
I'm guilty.
Like I don't mute them on my end or anything, you know, so they can come in here.
Yeah, if it's negatively affecting you, it's in your control. Like you're reading, you made a choice to read it. You made a choice to respond to it. You can make the choice to just take the negativity away. If it's not helping anything.
Correct. Yeah.
Well, I mean, the other thing about splitting it up, if we made it to where only people that are actually in the VC can even see the chat, then that way, and if we tried to keep it more like to the actual content to the live stream, if somebody was in there like refuting an argument in some way, I mean, it'd be easier to be like, hey, can you jump on your mic and actually, you know what I mean? Because there is a lot of potential, like especially when people get into it. I mean, not that it always has to be about debating, but a lot of people do get all debate hyped up in there, and then it can be very like, well, anyways, yeah, it can get kind of intense, like almost like overclogging the chat in a sense with a bunch of other side arguments. But like one idea is like we could have like another text channel right above that one that's called like audience text or something like that, or whatever the name would be. And then basically for everyone who's not actually in the VC, they could be in there. Or I mean, there's other channels as well, but I'm just saying in terms
Well,
of.
you've got a
I'm just talking about
you got a
like,
VC text, don't you? A VC text chat.
there's other text chats, yeah. But I mean, related to the live stream, there's just the main one. So what I'm saying is that related to live stream one, that's the like it's kind of like about the idea of like, do we need to at some point like redirect the traffic of the overall live
Maybe
stream,
so.
texting and typing?
Maybe so, right? Because I will say that's one thing 24/7 did, I guess, and what just became the normal thing was there's this whole other room away from the live stream that's just super toxic and has all kinds of anti-flat earthers in there. And then occasionally people would like want the blood, they'd want the animosity, and they'd go in there and they'd go on, 10v1 with the Globers in chat or whatever. But for the most part, no one really saw it. Like if it's more about that, but it's whatever, bro. Like I don't even care because I think the solution is certainly like just hide them if you want to. That way everyone can get what they want. You don't have to see it. You can see it. It's whatever. Like I will say, like a second ago, I showed a blocked message and it was like, it added me and was like, why are you running away from me, pussy? And I'm like, oh my God, like what am I doing, dude? I'm blocking these back up. So, you know, it's it's like the best of both worlds, I think, if people personally do it themselves.
Also, they always dodge your questions, so it's like, really? Like, even when someone talks to you, like, they just dodge your question.
Yeah, so then the text, it's like 10 times worse, right? I mean, and that's why when I was on that after show last night, bro, from the Modern Day Debate after show, like the new tactic that they were doing is like talk for 5 minutes, make like 30 claims about me, and then hope that some of them get lost in the sauce, though I don't remember them or whatever, right? And then just kind of talk past me. So that's enough to worry about, is like making sure the conversation's like honest back and forth in voice. Like text is just a different level. I mean, just go read my comment sections. It's futile pursuit, man.
Well, that's
Yeah, and you remember too. You remember back in the day, like in the early days on 24/7 when we were all there, like building it together at the beginning. But we always had like a debate text room, which was just for debate texting. So there's that idea as well. We've talked about even having like live stream 2 more be used for debates, and then that would more be like the debate text channel, as it were, or that type of channel where, because some people like really just want to be going back and forth, like sometimes like Gleam will be in here and it's like every other message, like he's going full on with someone, and it's like, It is
Yeah.
actually. I mean, it can be good live stream content though, because there's resources and people can follow it as well. It's kind of like a side thing happening next to the voice, you know. But at the same time, it can play the other direction where it's just like, whoa, like, yeah, it's kind of like a when it gets active, it can be probably pretty a little bit hectic.
I think if it was just about some type of information, it's fine, you know. Like I don't know. There's pros and cons to all of it, pretty much. Like if it's actually just about information, then it's cool. It's actually like it's an added benefit. I think what these a lot of these people are doing now, right, is they go listen to the live stream and then they sit in the chat. And so they're a few seconds behind, but they'll like make comments about the live stream. They're not in the VC, so obviously they're listening to the live stream, right? And so the truth is they just want to be a part of it. If you created a room where they weren't a part of it, then they would feel left out, you know.
Well, I guess if it was the way that where you have to join the VC to be able to text in the main VC text channel, it would be doing that thing basically, which means that not
Yeah,
anyone can just type in there.
They would not even want to come, right? Because they're going and listening to the live stream, and then, by the way, I'm not saying that if they didn't want to come, that's necessarily a bad thing. Like I'm just saying that they're going to the live stream, listening to the content, and then texting, right? Like, I don't know. I'm sure there's both sides. I mean, some people come in here and don't listen to the voice at all, I guess. Or they come in here and then they mute. They stay on mute. You know.
Sometimes I can't be in VC, like I can't actively talk, but I can text. So I want to listen to what's going on in VC and then have my own conversation in chat.
Yep.
But I have several people blocked now that it's helped me a lot. Like, because that would set me off and then it would overflow into the VC, my attitude, right? So now I don't have that. Like, I mean,
Same.
I think I have 6 or 7 blocked that there was no need, but I give them the opportunity. Look, I'm fixing to block you because of that comment. Either apologize, right, and let's move on, or I'm going to block you. And of course, none of them, not one has apologized. So I just block them, you know, and it was their choice.
Yeah, I mean, I would say Left Lane is a guy that will occasionally apologize if he says something wrong. Like, and I apologized to Left Lane earlier. Yeah, there are like exceptions. Like I misunderstood what Left Lane was saying earlier, and then I'm like, oh my bad, I misinterpreted. Like I don't know why that stuff is so difficult, but I will say, man, like that I used to do the same thing, and like I would come in here, and back in the day when I come in here, it was like as soon as I came in, like 20 people, it's like they were just waiting or something, and they would just spam insults, you know, to me or whatever, and I would like
I used to
start
wonder why.
communicating. I would start communicating with them in the VC, and everyone else is like, "Bro, we don't care," you know. Like, why are you debating a dude in text? We're all in VC, right? And like they'll kind of get you worked up, and then like so, it's not really worth it. It's better to just hide it.
Bro, I'll tell you what bugs me the most is when people are delusional about who you are or they try to guess your intentions. Like I got a text on the Witsit versus Dr. H versus Bob the Science Guy that I clipped. And this dude, he said, I think I've figured Witsit out. He's created a dialogue tree that guides people into certain directions so he can see out the debate by not talking about FE at all, just waffle on about our model. He clearly has studied Darth Dawkins, who also is another dumb grifter. And it's like, dude, you don't even know Witsit at all. And he would go to the Globe if you just give him proof. Hilarious.
Yeah, and I have no idea who that is. He's
Oh,
clearly
yeah.
studied the guy that he actually has no idea who he is.
No.
Yeah, it is weird. But like I actually kind of brought this up on the they don't just do this to me either, though, by the way. They do it to any flat earther that makes a good argument. And I pointed this out on the chat, like so I was like, yeah, I mean, just so you guys know, when you just like spam insults, the moderator was like, I was a mod in the chat on MGD, and I was trying to tell them not to insult you. I'm sorry, man, if I didn't get to all of them. And I'm like, well, to be fair, for you to have gotten to all of them, you would have had to delete like hundreds of comments, right? That's all that there was. And the main one they do is call me a grifter. So I called them out on that show. I'm like, basically, you're saying that that means I don't think the Earth is flat. I'm intentionally lying and deceiving people into thinking that it is, so they'll somehow so I can sell them something. That's what grifting means. And then they all kind of, I'm like, I think you guys are coping when you hear first you
Wait, did
go through
someone
this.
actually say that?
Yeah.
Because that is actually for real delusional if they think that. I'm just saying.
I know, right? So
I'm not. It's not even
first,
an insult. I'm not even trying to insult them. I'm saying there. It's like that's an actual like psychological term, like delusion, like that. If they think that is what the truth is, it's so far from the truth that it would. They're in a delusion, or they're purposely just trying to spread a false narrative or something. Yeah.
but don't you agree? It's what I said. It's because they're coping. So like first it was, which is super stupid, and or flat earthers are super stupid in general, right? It doesn't have to be personal to me, but and then it's like, well, they listen to more and more of us, and you can't really say we're stupid. Like we're clearly not stupid. We're intelligent, articulate, and researched. We're very knowledgeable about these things. We're constantly learning things, and we're clearly not stupid. So that narrative has kind of slowly fallen off. I mean, they'll still generalize it, but they won't say it about specific people. So then it's moved to we're grifters, because if the person is really smart and thinks the earth is flat, that messes with them, right? They're like, how can it, because I have to convince myself that flat earth is so easily disproven that no real intelligent person would believe it. So if these are real intelligent people that believe it, then in order to maintain my belief that it's so easy to disprove that no real intelligent person could believe it, I have to create a narrative that actually they don't believe it and they're lying, claiming they believe it so they can try to get money out of people. So it's actually a cope. It's just a method of coping. That's
Yeah,
literally what it is.
I,
that
I
was
put my
great.
money on that one too.
I love
What do
that
you
they were
say?
listening to that too.
I said that
Yeah.
that sounds very, very reasonable to me. I put my money on that bet.
Yeah. I mean,
Yeah, I
I
was just
never
gonna
had
With
that
it,
say.
experience. I
is
always
they
thought
wrap
that.
that in a compliment sandwich that was like a compliment to you for being smart, but you were too smart to be a flat earther, therefore you're a grifter.
You're a liar, yeah. Yeah, and then I was on that show yesterday. I call this out because I was like, it's like the fact that you guys call me a grifter is insane. And then Mark Reed, he jumps in. He's like, I'm not gonna lie. I've implied that you're a grifter and thought that you were a grifter many times because, well, for one, you're too smart to think the earth is flat. You seem like you're intelligent, so you're too intelligent to think the earth is flat. So then, I thought that you were grifting. But he just admitted that. He doesn't understand that the psychological implications are that he has to lie to himself and then convince himself that, no intelligent person could ever think the earth is flat. And if you have to think that, then you're not even able to look at the true information, right? You still
Well,
have to create a
I wouldn't
caricature of
be able
flat earth.
to. I like face to face with Mark Reed. I wouldn't be able to not swing on him. I can't stand him. I would definitely fight him. Like
Well,
no
that
doubt about it.
also technically is a delusion because that's not the case. He's projecting some kind of a false concept that like his it sounds like almost like his insecurities of his intelligence are projected onto you because he knows you're actually right about something and he can't think of himself as currently being stupid to then have to realize that you're actually correct.
Well, another good
Yeah,
example.
bro.
Just now, 2 hours ago, Shane and Witsit started giving their explanation of what their new findings. 5 Globers in a row had the same exact response. All 5 of them could not steelman the argument. All 5 of them claimed that Witsit's information was incorrect.
Yeah, exactly.
Clockwork.
Yeah, just preemptively and assumptively say it's wrong. Then he said the other reason is because every time that I'm scared to debate people that are super knowledgeable on the subject, like MC Toon, and I only want to go find people that are new to the subject to debate, so I can make it look like I'm right. And that every time somebody with credentials or any type of expert wants to debate, I run away from them. And in reality, it's the exact opposite. I am like begging people with credentials to come onto my show. I'm begging James. I reached
Yeah.
out to James and said, I don't want to be set up with random people that don't know much about it anymore. Can you please only set me up with someone that's got some type of credentials or academic reputation or, some type of expertise and we can have a conversation within their field. That's like, I literally have the text proof that I asked for the exact opposite. And I've obviously even debated these anti-flat earthers dozens of times. And the reason I don't is because of stuff like MC Toon said something about my daughter. something like replying to PhD Tony, implying that CPS should basically take my daughter because she's going to be told all this false information and it's dangerous and stuff like that. Now, like,
That's
you
a
cross
Christian.
the line. You talk about like my daughter, right? So, like, so I don't debate these people out of moral principle. It's nothing to do with anything else. And so
Yes.
that's just another cope. That's just a lie. So anyway, I'm just saying, if you think about it, it's not a big deal because they're coping. And if you realize that, then it's like, well, okay, buddy, you can say it about me, but it's just like word salad. And I'll stop talking. Like word salad is the same thing. That's a cope. Because first it's like you guys are stupid. So then you point out like, oh, the conjugate geometric expression of a centrifugal divergence, centripetal convergence. So you have the hyperbola and the toroid, right? Or you have the pure potential inertial expression. Whatever, however you explain it, like the
Yeah, I mean,
dielectric.
I'd rather. Sorry to interrupt, but I'd rather hear more about that in every detail than listening to someone just ignoring that and calling it word salad. So like if that's what's happening, we should just moderate more for that so we don't, because that's just ridiculous. Because I'm just saying I'd rather spend our time instead of talking about those people who do it or letting them do it, we should just actually, because that's like what you just said right there is amazing. Like I'd love to hear that actually broken down and knock on into like, yeah, just the word salad bickering, because that's in my opinion where they win in a lot of ways. Like from my viewpoint of it, when they get us into like get anyone into just like bickering on that lower vibration, then they're literally winning because now we're not actually discussing truth and progressing forward.
Yeah, I actually kind of agree. I guess to make that point and close it up, like I guess so. Like when we're in a debate and you say that, and then they say that's just word salad. Like I guess I don't know if it's ego or what, right? But it's very hard for me to not call it out in the moment because in my mind, I think that someone in the audience is desperately listening to the debate, pulling for the other guy, and so when they say that, they're like, "Oh, it must be word salad," and then they all say it, and I'm like, I don't know. I want to pull the cope away from them. Like, no, it's not. Let's go through the phrase word by word, right? So you can understand it's not word salad. But anyway, I guess my meta here is that like if they attack you, instead of what's helped me a lot, instead of like viewing it as like some type of big deal or whatever, really it's just them kind of coping. They have to create a different narrative. And Gio and I talked a lot about this. Like, what is it like they can't receive the information? Like, what's going on? They can't hear it that comes from us or whatever. So anyway, yeah, that's my point. I think it's just like kind of cope. So I don't think it's like I think it's like a sign of victory, I guess is what I'm saying.
I honestly think that a big reason why, like, like this is definitely Incarnation, the guy that was just making fun of Whitson again, calling him, saying that it was his acting smart or whatever he was saying the last few times. But anyway, like people like that, I don't think they can even begin to hear, right? Because of reasons like, typing in flat Earth and then like going and watching Professor Dave for like an hour and then like that's it. Like I really think like people like Professor Dave is a big part of it. That's my opinion. I mean,
Well,
not
but if you
all of
think
it,
about
obviously.
this,
But
like kind of with what Gio's saying, right? Like the smarter people that actually are curious about truth and stuff, like if they hear that statement, they just want to know what it means. And so like Gio's right, actually. They kind of win when we're like so baffled at the tactics that we talk about it or we playing them out with them. Because that's this like niche minority bad faith group of people. And but like the average person that listens, they may be like, this seems like this seems complicated and I'm not really familiar with it. But if someone's like wanting to know the truth or how things work, they're gonna be like, I want to know what that is. And I get that email all the time. Like when I first heard you, I thought that they were right when they said that you just use word salads or word salad or overcomplicated words to try to sound smart to woo the audience and to trick them, and that you don't actually know what you're talking about, and that they're like scientifically illiterate phrases that mean nothing. But then what I did was I went and Googled the words you were using and how you were using them, and then very specific scientific papers came up, and you were actually talking about like very precise, specific scientific phenomena, and it
Yep.
is real things. And then they're like, that totally woke me up because I found out that the quote unquote best that side has all say that it's just word salad and they can't actually ever respond to it. So when I found out that it's not word salad, I'm like, wait, is this all the Globe has? Is it just like hand wave dismiss it? And it woke them up.
Yeah, so a truth seeker will see truth. Yeah. Yep.
Yeah, man. So it like backfires. I even told them too. I'm like, by the way, you guys are recruiting flat earthers that way. I mean, I guess keep it up, whatever.
Well, yeah, because like such an obvious tactic to try to evade or hide something shows that there's weakness on that side. Of course, yeah. Well, so I would like really never myself, like especially in a debate, just call something out as word salad anyways. I mean, word salad is when there's like words that are just smashed together that have no correlation or no meaning in relation to each other. So in any of these discussions ever, I mean, has anyone ever actually heard real word salad? I don't think so. That person would probably be muted because everyone would be like, what is that guy saying? Like, that's not even English, like it would just be incomprehensible. So could it be even, to say that really no one's ever even done word salad ever? And every claim of that is just to completely divert and try to throw a bomb on the discussion to try to derail it by trying to go to some personal and trying to just disregard everything you said, even though what you actually said was, there was, like you said, there's potency to each and every word. And if they were to even begin to understand what that is, then it's like more potential truth that apparently they're not either ready or just not even kind of emotionally in the state to actually want to take on and actually look into.
Yeah, for sure. I guess what you'll just so you know, like what they were saying last night, their new tactic is, well, yeah, sure, you're using the actual definition of word salad, but that's not how we use it. We just use the colloquial sense to mean that even though the words you're saying do have a meaning and coherently make sense together, they don't actually make sense in reality or something. So they're just misusing the word. Yeah,
Scientifically, maybe.
which means they're disagreeing with the
Official.
argument or the conclusion, not the words.
No, I would disagree. It's not that they're disagreeing with your argument; it's that they don't understand your argument. There's a distinction.
No, I agree. I agree. But whenever you press them about how it's word salad, they'll always just like deflect to telling you why they think that your argument or conclusion's wrong with some random example. And I'm like, that's not what word salad means, bro. But I
Left
found
lane.
out, dude, that it doesn't matter. They're all gonna say it no matter what because of what you said, that they don't understand the argument. And I found out that no matter what, they're gonna say that everything I bring up is quote mining or cherry picked, and that there's no way they're just gonna say it regardless because there's no way to stop them. Like if they're anonymously in the chat doing it, like why would they care if you corrected them in front of everyone? They'll just keep doing it. So like you just have to kind of take it on the chin, I think.
Yeah, whatever with it. We just know that you always quote mine for your cherry picked word salad. We get it.
Well, dude, like I'm kind of curious because like,
baby,
dude, they haven't tried any of that shit on. I mean, like, here, I know. They just kind of avoid it.
I
Are they
think
blaming you?
that should be called the word salad fallacy.
I don't understand, therefore word salad.
Yeah, just to call something word salad because you don't understand is a logical fallacy.
I mean, that only works like if you don't publicly attach your name to it, and then people later come by and coherently argue the point. Because then you're like, oh, well, if you didn't understand, but everyone else did, doesn't it just make you look stupid?
Yeah, that's what I finally realized.
Yeah.
Like I'm saying, I had to grow in that sense because like at first I would be like, I'd feel like I needed to prove myself. But then I got so many messages that were like, bro, that don't worry about that. That's what woke me up. I'm like, oh, okay, well then, the people that want to see the truth do, and the people that don't. So it's like if Shane and I sit here and explain to someone every detail about this like 60 nautical miles per degree thing, and they don't really listen to any of it the whole time, and they're only going to listen to the idea once they go listen to MC2 tell them why it's wrong and claim what we're saying, right? Then they're not listening to you anyway. So like they're not. It doesn't really matter. Like it doesn't matter what I say. These people are going to wait till it's over and say word salad.
I think they do understand, actually, a lot of them. I think they just, in their mind, you're a flat earther. So what you're saying is automatically wrong. Right? So they
You're
just,
breaking up.
they don't even listen. They don't care.
You're breaking up, Rakia.
Yeah, I kind of have a meme exactly for that, right? I feel where you're going, man.
My only argument
go there too.
My only argument against Rakia's last point would be that they all fail to be able to steelman.
Yep.
If you want to make
Well-
the statement that they do understand, then they should at least have a half-assed excuse for being able to steelman it, and then go back to gish galloping or whatever tactic they're going to use.
Well, it's the same way as if
Yeah, I was
like
going to
you're
expound on.
like you're arguing with a female, right? And they're not listening to what you're saying. They're just waiting for the next opportunity to interject something that is completely irrelevant, right? You know what I'm saying? So they're not going to listen to your argument. They're just waiting for their opportunity to go ahead and say what they say in here every single day, right? Especially like the conversation earlier where it's like, all right, here's the mathematics. Here's exactly how the transform took place of our visual space being spherical, being transformed into a sphere beneath your feet. This is how it's all laid out. This is how it all works. And they just want to go back and not pay attention because they know if they pay attention and they actually comprehend it, that their whole entire world view literally dissolves away. So they can't do that. They can't listen to it.
But
They
that's
won't.
crazy. That's crazy. Then that to even understand how someone could know that what they believe is that vulnerable, but still like sit there comfortably with it anyway, to the point that they know they have to intentionally block out information to do so. That's weird. It's like, hey, look at this NASA video, and then they like literally like they run out the room or something and talk about how they know NASA's real. So this, I mean, this is like so funny. This is the conclusion of the situation. It's like they claim that it's linear and that linear won't work on a flat Earth. Well, on a flat Earth, it would be logarithmic, and the actual evidence shows that it's logarithmic in reality, and they actually have to make up an excuse as to why it's logarithmic. And then they turn around and claim that proves that it's linear and therefore can't work on a flat Earth.
They invert it with making the globe spinning. Yeah.
It's crazy.
Yeah.
There's really no distinction. This is the way the globe always works. It hijacks reality, comes up with some excuses that basically ends up saying that the globe Earth model's prediction is exactly what the flat Earth prediction is. That's what they do with everything. Right? It's like, okay, the stationary Earth's prediction is that when using difframetry, you're not going to detect motion of Earth through space because there is no motion. So what do? They change their whole model to match our prediction. They do the same thing whenever the distant galaxies looked like they were moving in relation to the Earth. The Earth looks like it's in the center. The Earth looks like it's in the center. So the Earth looks like it's in the Earth looks like it's in the center. So they changed the model to say that it's accelerating and expanding. And now the new heliocentric model's prediction is that the Earth will always look like it's in the center. And they did the same thing here. Like a flat Earth, you would have logarithmic relationship. So they say, oh, well, there's refraction right where it would become more logarithmic on a flat Earth. So actually, that's the globe prediction. So of course, they end up having unfalsifiable claims because it does match reality in the end because they hijack the flat Earth to do it, just like flying a plane over a flat and stationary Earth, just like doing engineering and plane survey, assuming that the Earth is flat, neglecting curvature, just like establishing localized plumb lines as if the Earth is flat and perpendicular to the vertical plumb line, et cetera, et cetera. Almost every situation, they just hijack a stationary flat Earth and claim that's actually the spinning globe prediction. Which you would have to do that if the Earth's actually stationary and flat, right?
That is tough from from a whole position to be based upon data that already validated the opposite of what they're claiming it is.
Yeah, man.
That's tough.
But dude, didn't they all go around and repeat this phrase right here? Oh, still no evidence for flat Earth. It's like, what?
Hey, yo, I got a counter argument for the train tracks. Run it.
Okay. Is perspective Euclidean?
Yeah.
Oh, okay. Do you agree that one of the primary postulates of Euclidean geometry is that parallel lines do not converge?
Yeah.
Are railroad tracks
Fundamentally.
parallel lines in actual reality?
Yeah, 100%. I work on railroad tracks or whatever.
Nice. Do they appear to converge?
Yeah, due to gravity.
All right.
Going refraction, man.